Welcome, part 17. Yep, still the same day, doing two parts in one day. It's probably because I'm trying to catch up. As you can see from here, I'm still at part 17, even though my streak is already at 22 days. That's insane. So I need to catch up with my parts. Like, I want to sync it up, like, the number of parts would be the number of streaks. So yeah, I think that makes much more sense. So yeah, I'm gonna pump up some parts in each day. Kinda had a rough time the other day, but yeah, today. Okay, cool. Intro to percents. Let's go. Am I recording?
We're asked to shade 20% of the square. We're asked to shade 20% of the square below. And before doing that, let's just even think about what percent means. So let me just rewrite it. 20% is equal to 20. I'm just writing it out as a word. 20%, which literally means 20%. Let me break it out, which is the same thing as 20%. And if you're familiar with the word century, you might already know that this cent comes from the Latin for the word hundred. So this literally means you can take cent, and that literally means 100. So this is the same thing as 20 per hundred. 20 per hundred. 20% means you're really going to, if we want to shade 20%, that means we want to shade, if you break up the square into 100 pieces, we want to shade 20 of them. 20 per hundred. So how many squares have they drawn here? So there's, let's see, if we go horizontally right here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. If we go vertically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10 by 10 square. So it has 100 squares here. So if we want to shade this, or another way to say it is that this larger square, I guess that's the square that they're talking about, this larger square is broken up into 100 smaller squares. So it's already broken up into the 100. So if we want to shade 20% of that, we need to shade 20 of every 100 squares that it is broken into. So in this, we'll just literally shade in 20 squares. So let me just do one. So if I just do one square, just like that, I have just shaded 1 per 100 of the squares. 100 out of 100 would be the whole. I've shaded one of them. This would be, that one square by itself would be 1% of the entire square. If I were to shade another one, if I were to shade that and that, then those two combined, that's 2% of the entire square. It's literally 2 per 100, where 100 would be the entire square. So if we wanted to do 20, we do 1, 2, 3, 4. Actually, if we shave this, if we shade this entire row, that will be 10%, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we want to do 20, so that'll be one more row. So I can shade in this whole other row right here, and then I would have shaded in 20 of the 100 squares. Or another way of thinking about it, if you take this larger square, divide it into 100 equal pieces, I've shaded in 100, or I've shaded in 20 per 100, or 20% of the entire square. Hopefully that, the entire larger square, hopefully that makes sense.
It does.
Show 109% by shading. So just as a bit of a review, 109%, if we were to write it out, would literally be 109%, which is the same thing as 109 per, and I could write cent again, but that's getting old. Cent means 100, so it literally means 109 per 100. Per 100. If you had 100 per 100, you're dealing with a whole, but now we have more than a whole. We have 109 per 100. We can actually write this as a ratio or as a fraction. This is the same thing as 109 per 100. It's the same thing as 109 over 100. So let's shade that in. So we have a whole here. So we can consider this square a whole. In the last video we counted, this is a 10 by 10 square. It is cut up into 100 pieces. So if we want 109 of those 100 pieces, what are we talking about? Well, that means we're going to shade in all of the 100 right over here. Let me do that in a new color. So we'll shade in all of this. We'll shade in all of this right here. That would be, if you just shaded that in, that would be 100%. That would be 100 over 100, or 100 per 100, or 100%. I think you're getting the meaning of all of this here. I just don't want you to just memorize the steps. This really just means 100 out of 100, or a whole. And you can see that this is the whole square. That's 100 out of 100 right there. The question is saying, show us 109% by shading. So we already did 100 per 100, but we need to do another 9. So let's shade in another 9. So now we have a 1, 2, 3, 4, 5, 6, 7, 8, 9. So this piece right here, you could almost view that as, well, that is 9%. That is 9% of an entire square. This is 100% of an entire square. If you consider this whole thing plus this blue area right over here, you are talking about 109% of one whole square. Hopefully that made sense.
Yo, this one isn't shaded. It's like 99% only, man.
Hopefully
look at this one.
that made.
Okay, cool. Percent from fraction models. I'm not wearing any earphones today.
So we're told the square below represents one whole. So this entire square is a whole. And then they ask us what percent is represented by the shaded area. So why don't you pause this video and see if you can figure that out.
Yeah, bro, it's 7%.
So let's see. The whole is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections, of which 1, 2, 3, 4, 5, 6, 7 are actually filled in. That's the shaded area.
Yep.
So one way to think about it is 7/10 are shaded in. But how do we express this fraction as a percent? They're asking for a percent. Well, remember, percent, it literally means per 100. Cent, same root as the word 100. You see it in cents or century. And so, can we write this as per 100 instead of per 10? Well, 7 per 10 is the same thing as 70 per 100, or 70%. And how did I go from 7/10 to 70 over 100? Well, I just multiply both the numerator and the denominator by 10. And once you do more and more percent, you'll get a hang of it. You say, oh, 7/10, that's the same thing as 70 per 100, which is 70%. Let's do another example. Here we're told 100% is shown on the following tape diagram. So just this amount right over here is 100%. And then they ask us what percent is represented by the entire tape diagram. So by this entire thing right over here. Pause this video and see if you can answer that. Well, one way to think about 100% is equivalent to a whole. And now we have 3 times as much of that for the entire tape diagram. So you can view this as 3 wholes, or you could say that's 100%. We have another 100% right over here. And then we have another 100% right over here. So the whole tape diagram, that would be 300%. Let's do another example. This is strangely fun. All right. Okay.
Yep, strangely fun.
Now, let's see. It says the large rectangle below represents one whole. All right. So that's this whole thing is one whole. What percentage is represented by the percent shaded area? So pause the video and see if you can figure that out again.
All right, let's see.
So let's just express it as a fraction first. So we have a total of 1, 2, 3, 4, 5.
6 is shaded in. This is real fun. How about 4 to 26? 6 is shaded in. Like
6, 7, 8, 9, 10, 11, 12.
If pertaining by percent, let's see. Well, if we multiply that by 5, it's like 30%.
13, 14, 15, 16, 17, 18, 19, 20 squares. So out of those 20 squares, we see that 6 of them are actually shaded in. So 6 20ths, can we write that as per 100? Well, let's see. To go from 20 to 100, I multiply by 5. And so if I multiply the numerator by 5, I'll get the same value. 6 times 5 is 30. So 6 per 20 is the same thing as 30 per 100, which is the same thing as 30%, which literally means per 100. So this is 30%. Let's do one last example. Here we are told each large rectangle below represents one hole. So this is a hole, and then this whole thing right over here is another hole. What percentage is represented by the shaded area?
180%.
Again, pause the video, see if you can answer that. So this one, we have shaded in a hole, so that is 100%. And then over here, we have shaded in 1, 2, 3, 4/5 of the hole. So 4/5, if I want to express it as
Like
per 100,
810 or 80
what
by
would it
100.
be? Well, 5 times 20 is 100, so 4 times 20 is 80. So 4/5 or 80 hundredths is filled out here, or you could say 80 per 100, which is the same thing as 80%. So this right over here is 80%. So what percent is represented by the shaded area? Well, we have 100%, and then we have 80%. So we have 180%. It's more than a whole. If you have a percentage that is larger than 100%, you're talking about something that is more than a whole. And then we see that. We have a whole right over here, and then we have 80% more than that. So let's assume that this entire square represents a whole. And we can see that part of it is shaded in blue. What we're going to do in this video is try to represent the part that is shaded in blue as a fraction, as a decimal,
Wow, okay.
and as a percent.
And 60%.
So pause the video and see if you can do that. Well, let's first think about it as a fraction. So the whole is split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal sections. And 6 of them are filled in. So the blue represents 6/10 of a whole, or represents, you could say, just say 6/10. And you could also rewrite that if you divide the numerator and the denominator by 2. That's the same thing as 3 over 5.
Whoa.
Fair enough? Now let's represent it as a decimal. What decimal would it be? Pause the video again and see if you can do that.
0.6.
Well, 6/10, we could literally just go to our place value. So that's the ones place, we have a decimal. And then you have your tenths place. And so we have 6/10, so you could just put it right over there. We are putting a 6 in the tenths place to represent 6/10. Now what about a percentage? Well, percent means per 100. So one way to think about it is 6 over 10 is the same thing as what per 100? That is equal to, if we multiply the numerator and the denominator by 10, that's the same thing as 60 per 100. Or another way of thinking about it, 60 per, instead of 100, you could say cent. And so this would be equal to 60%. Let's do another example. So here, once again, our entire square represents a whole. So see if you can represent this as the part that's shaded in blue as a fraction. Pause the video and do that.
Fraction is 44 over
Well,
100.
you can see that this is a 10 by 10 grid. So there's 100 equal sections here. 100 equal sections. Each of these squares represents 100.
11 by
And how many of them are there? Well, let's see, this row is 10, 20, 30, 40, and then 1, 2, 3, 4. So this is 44 over 100. 44 hundredths. And we could actually represent this in other ways. We could divide the numerator and the denominator by 4, in which case you would get 11 over 25. That's another way to represent this same fraction. Now what about as a decimal? Well, 44 hundredths, you could say, well, we have your ones place. And then this is the same thing. You literally just say this is 44 hundredths. This is another way of representing 44 hundredths. It's 4/10, and 4 hundredths is 44 hundredths. And then if you were to do a percent, well, this is 44 per 100, or 44 hundredths. But even here, I like looking at it as 44 per 100, or 44 per cent. So this is going to be 44%. And we're done.
Oh my god. Okay. One, two, three, four, five, six. 138. 50. Oh my god, why is it so slow? Okay. But am I really recording? Am I really recording? Okay, 15 minutes in and my hair sucks. Oh wow, that's insane. What? No way! This is 5 by 5, right? Holy shit, and 50% of it. What the fuck? 1, 2, 3, 4, 5. Yo, what the hell? This is in 50%? 1, 2, 3, 5, 10, 13. Yo, what the hell? Oh, it's tricky. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 10, 13, 25. Holy shit. So 13 times 4, 12, 1. Oh my god, 152, bro. Yo, that got me. Let's try again. Oh, wow, I already know this. It's like 30%. 40. Oh wow, okay, it's 175. 110, I suppose. Cool. No. Okay. Okay, cool. Fraction would be 9 over 10. 0.9 and 9. 1/2, 0.5 and 50. Oh, so 23 over 100. 90%. Oh wow, this is 81. Right? Cool. I'm having, holy shit, that's a lot of videos and articles. Map history was 4. Oh my god, I'm gonna make it. I don't know. Let's see. Converting decimals to percent.
Percent literally means per hundred. That's where the word comes from. Cent, from cents or century or any of those words, mean 100. So if someone tells you 7%, and I'm separating the word so it makes a little more sense, they're really saying 7 per hundred. This is the same thing as 7 per hundred, which is the same thing as a fraction as 7 per 100. With that out of the way, let's see if we can write 0.601 as a percentage. Well, we essentially want to write it as something over 100. So you could view it as, I'll just rewrite this part right over here. You could write it as 0.601 over 1. This is obviously the same quantity. You divide anything by 1, you're still going to get that same anything. And I'm going to multiply it by 100 over 100. Obviously, this won't change the value. This is just 1 here. Or rewrite it 1. The way, let's see as 7 per 100. With that out of the way, let's see if we can write 0.601 as a percentage. Well, we essentially want to write it as something over 100. So you could view it as, I'll just rewrite this part right over here. You could write it as 0.601 over 1. This is obviously the same quantity. You divide anything by 1, you're still going to get that same anything. And I'm going to multiply it by 100 over 100. Obviously, this won't change the value. This is just 1 here. But what this does is it'll give us a fraction in terms with the denominator being 100. So the denominator, if I multiply these two characters right over here in the denominator of our product is going to be 100. If I multiply 0.0601 times 100, what am I going to get? Well, every time I multiply it by a multiple of 10, or every time I multiply it by 10, I'm going to shift the decimal over to the right once. So if I multiply it by 10, I'd get 6.01. And if I multiply it by 10 again, or if I multiply it by 100, I'm going to get 60.1. So 0.601 times 100 is 60.1. Let me rewrite that again. If I were to write 0.601 and I want to multiply it by 100, shift the decimal once, I multiply it by 10. If I multiply it by 10 again, or essentially multiply it by 100, I get 60.1. So this is times 10, this is times 10 again. I've essentially multiplied it by 100. But now we have it in the form we like. We have 60.1 over 100. Or you could rewrite this. This is the same thing as 60.1 per 100, which is the same thing as 60.1%. And we'd obviously want to write it then as 60.1% as one word, or 60.1, and we'll just use the symbol, 60.1%. We are done.
It's so fancy.
Let's see if we can write 1.501 as a percentage. Now we really just want to write this quantity as something over 100. So what we can do is we can say that this is the same thing as 1.501 over 1. We haven't changed this value. And let's multiply it times 100 over 100. When we do this product, and I haven't changed the value, this is just multiplying something times 1. But when we do it, we're going to change the way that we're representing it. The denominator now is going to be 1 times 100. So that's pretty straightforward. That's just going to be 100. And then the numerator, we're going to want to multiply 1.501 times 100. And so this is going, if we multiply this times 10, we would move the decimal 1 over. We want to multiply it by 100, so we want to multiply by 10 again. So we're going to move the decimal over to the right twice. We're multiplying it by 10 twice, or you're multiplying it by 100. This is multiplying by 10, this is multiplying by 100. So this is where the decimal is going to sit now. So we're going to get 150.1. And so we've rewritten 1.501 as 150.1 over 100, or 150.1 per 100. Let me write that. 150.1 per 100, which is the same thing as 150.1 percent, which is the same thing as 150.1%. And we're done. And essentially all you're doing, if you really want to simplify the process, we're multiplying this by 100 to get 150.1, and then we're saying that is the percentage. So you want to make sure that you write the percent there, or the percent symbol.
Okay, cool.
Let's see if we can write 59.2%. If we can write this as a decimal. Well, 59.2%, this literally means 59.2 percent, which literally means 59.2 per 100, which literally means 59.2 per 100. Which is the same thing as 59.2 divided by 100. And if we were to divide 59.2 by 100, what do we get? So this is the same thing as 59.2 divided by 100. So if we were to take 59.2, if we wanted to divide it by 10, we would move the decimal over to the left once. We would get 5.92. But we want to divide it by 100, so we move the decimal over to the left again. We're dividing by 10 once, and then we're dividing by 10 again. Divide by 10 twice, you're essentially dividing by 100. So you move the decimal to the left twice, you get 0.592, and we'll just put a 0 out here just to clarify things. And we're done. We've written 59.2% as a decimal. We essentially just divided this by 100, which is dividing by 10 twice, moving the decimal once to the left and then another time. Or, since we're dividing by 100, moving the decimal twice to the left, and we get 0.592. Let's write 113.9% as a decimal. So percent, this symbol right over here, literally means per hundred. So this is the same thing as 113.9 per hundred, which is the same thing as 113.9 divided by 100. So essentially, if we want to write this as a decimal, we just take 113.9 and we divide it by 100. And to do that, 113.9 divided by 100. If you divide by 10, you move the decimal once to the left. If you divide by 100, you're moving the decimal twice to the left. If we're doing it by 1,000, we would go to the left once more, 10,000. Each time you divide by 10, you'd go one step to the left, which hopefully makes sense. If we were to multiply by 10, we would be moving the decimal over to the right. And there are other videos that go into far more depth and the intuition behind that. But anyway, we're dividing 113.9 by 100, so move the decimal 2 spaces to the left. So the decimal will end up right over here. So this will be equal to 1.139. And we are done.
Cool, that's cool. How much more? We have one more video, an article, a video, and 4 more articles. Okay, cool.
Write 18% as a decimal and as a fraction in simplest form. So let's do it as a decimal first. So 18% is the same thing as 18 per hundred, or 18%. I'm actually separating out the percent word. It's going to be one word, but I'm writing it as literally percent. Cent means the same thing as hundred. So this literally means 18
decimal, and then
per hundred. Actually, I said I would do the decimal first, but we can start putting it into a fraction first. 18 per hundred as a fraction literally means 18 per hundred. We're literally doing, so we're doing the fraction first. This literally means 18 per hundred, or 18 hundredths. Now, if we want to do it, we could, from here we could go straight to a decimal, or we could do this fraction in simplest form. Let's do the decimal first, because that's actually where I said I would do first. So let's do that first. So how do we write it? So this is the same thing. This is the same thing as 18 hundredths. 18 hundredths. And we know how to write that in decimal form. It's 0.18. You could view this as 1/10 and 8 hundredths, which is the same thing, or 10 hundredths and 8 hundredths, which is 18 hundredths. So this is written in decimal form. And if we write it as a simplified fraction, we need to see if there is a common factor for 18 and 100. And they're both even numbers, so we know they're both divisible by 2. So let's divide both the numerator and the denominator by 2. So we have 18 divided by 2 over 100 divided by 2. And we're going to get 18 divided by 2 is 9. 100 divided by 2 is 50. And I don't think these guys share any common factors. 50 is not divisible by 3. 9 is only divisible by 3 and 1 and 9. So this is the fraction in simplest form. So we have 18% is the same thing as 0.18, which is the same thing in simplest form as 9/50ths. Now, I went through a lot of, I guess, pain here to show you that, look, this really just comes from the word, from percent, from per hundred. But if you ever were to see this in a problem, the fast way to do this is to immediately say, okay, if I have 18%, you should immediately say anything in front of the percent, that's that anything, whatever this anything is, this should be equal to that anything. In this case, it's 18 over 100. And another way to think about it, you could view this as 18.0%. So this is 18.0%. When you want to convert this, I just added a trailing 0 there. If you want to, just so that you see the decimal really, if you want to express this as a decimal without the percent, you just move this over to, you move the decimal to the left 2 spaces. So if we move the decimal to the left 2 spaces, 1, 2, this becomes 0.18. 0.18. Or you could immediately say that, look, 18% as a fraction is 18 over 100. When you put it in simplified form, it's 9 over 50. But you should also see that 18 over 100, and we have seen this, is the exact same thing as 18 hundredths, or 0.18. Hopefully, this made some connections for you and didn't confuse you.
Thus, made connections. Percent variance is variance, for example, is equivalent. Okay, they're obviously equivalent, yeah. First, or 1 half, or 0.5 multitude. Fraction. Simplified fraction. But 5, we have 3 over 10, 20, yeah, cool. 3 over 20. Whoa, simplified fraction form? It's gonna be 11.5, yo. Fraction percent. So let's convert 3/5 to a percent. Times 20. Whoa. Okay. It's 48. What kind of step is this? What the hell? What? It's supposed to be like this? Shot my backwards. Convert to percent, so divide by 100 to 0.03. That's what I did, right? Yo, what? Yo, if this is 1%, that's 0.1. But if it's 0.3, it's gonna be 0.03. No, 0.003. Yo, what the fuck? It's supposed to be like that? Oh, this is insane. So, let's see. I'm gonna write some stuff here. So 0.3 divided by 100. I got 0.03. Yo, why is it wrong? Oh, to a percent. Is this 30? Oh fuck, it's 30%. Oh, okay. I made a dumb mistake. Okay, cool. Uh, 34? 17?
Welcome to the presentation on ordering numbers. Let's get started with some problems, and I think as we go through the examples, hopefully you'll understand how to do these problems. So let's see. The first set of numbers that we have to order is 35.7%, 108.1%, 0.5, 13 over 93,
Yo, this video looks
and
like
1
from
and
2007 or something.
7/68. So let's do this problem. So the important thing to remember whenever you're doing this type of ordering of numbers is to realize that these are all just different ways to represent. These are all a percent or a decimal or a fraction or mixed numbers are all just different ways of representing numbers. And it's very hard to compare when you just look at it like this. So what I like to do is I like to convert them all to decimals. But, you know, there could be someone who likes to convert them all to percentages or convert them all to fractions and then compare. But I always find decimals to be the easiest way to compare. So let's start with this 35.7%. Let's turn this into a decimal. Well, the easiest thing to remember is if you have a percent, you just get rid of the percent sign and put it over 100. So 35.7% is the same thing as 35.7 over 100. Like 5%, that's the same thing as 5 over 100. Or 50% is just the same thing as 50 over 100. So 35.7 over 100, well, that just equals 0.357.
Why does my back hurt?
If this got you a little confused, another way to think about percentage points is if I write 35.7%, all you have to do is get rid of the percent sign and move the decimal to the left 2 spaces, and it becomes 0.357. Let me give you a couple of more examples down here. Let's say I had 5%. That is the same thing as 5 over 100. Or if you do the decimal technique, 5%, you could just move the decimal, so you get rid of the percent, and you move the decimal over 1 and 2. You put a 0 here. It's 0.05. And that's the same thing as 0.05. And you also know that 0.05 and 5 over 100 are the same thing. So let's get back to the problem. I hope that distraction didn't distract you too much. Let me scratch out all this. So 35.7% is equal to 0.357. Similarly, 108.1%, let's do the technique where we just get rid of the percent and move the decimal space over 1, 2 spaces to the left. So then that equals 1.081. So we already know that this is smaller than this. Well, the next one is easy. It's already in decimal form. 0.5 is just going to be equal to 0.5. Now, 13 over 93. To convert a fraction into a decimal, we just take the denominator and divide it into the numerator. So let's do that. 93 goes into 13. Goes into 13. Well, we know it goes into 13 0 times, right? So let's add a decimal point here. So how many times does 93 go into 130? Well, it goes into it 1 time. 1 times 93 is 93. It becomes a 10. That becomes a 2. 12. We get 37. Bring down a 0. So 93 goes into 370. I think let's see, 4 times 93 would be 360, it'd be 372. So it actually goes into it only 3 times. 3 times. 3 times 3 is 9. 3 times 9 is 27. 27. So this equals, let's see, this equals, if we say that this 0 becomes a 10, this becomes a 16, this becomes a 2, 81. And then we say how many times does 93 go into 810? It goes roughly 8 times. And we could actually keep going, but for the sake of comparing these numbers, we've already gotten to a pretty good level of accuracy. So let's just stop this problem here, because the decimal numbers could keep going on. But for the sake of comparison, I think we've already got a good sense of what this decimal looks like. It's 1.138, and then it'll just keep going. So let's write that down. And then finally, we have this mixed number here. And let me erase some of my work, because I don't want to confuse you. Actually, let me keep it the way it is right now. So there's 2 ways. The easiest way to convert a mixed number into a decimal is to just say, okay, this is 1, and then some fraction that's less than 1.
Or we could convert it to a fraction, an improper fraction, like, oh, actually there are no improper fractions here. But let's do it that way. Let's convert to an improper fraction and then convert that into a decimal. So 1 and, actually, I think I'm going to need more space. So let me clean up.
That's going to be like 75 over 68.
There. Okay, space to work with now. So 1 and 7 68. So to go from a mixed number to an improper fraction, what you do is you take the 68 times 1 and add it to the numerator here. And why does this make sense? Because this is the same thing as 1 plus 7 over 68, right? 1 and 7 68 is the same thing as 1 plus 7 over 68. And that's the same thing, as you know from the fractions module, as 68 over 68 plus 7 over 68. And that's the same thing as 68 plus 7 is 75 over 68. So 1 and 7 68ths is equal to 75 over 68. And now we convert this to a decimal using the technique we did for 13 over 93. So we say, let me get some space. So we say 68 goes into 75. I have a suspicion I'm going to run out of space. So 68 goes into 75 one time 68. 68, 75 minus 68 is 7.
Wow.
Bring down to 0. Actually, you don't have to write the decimal there. 68 goes into, ignore that decimal. 68 goes into 70 one time. 1 times 68 is 68. 70 minus 68 is 2. Bring down another 0. 68 goes into 20 0 times. And the problem's going to keep going on. So, but we can, I think we've already, once again, gotten to enough accuracy that we can compare. So, 1 and 7 68ths, we've now figured out, is equal to 1.10. And if we kept dividing, we'll keep getting more decimals of accuracy, but I think we're now ready to compare. So all of these numbers, I just rewrote them as decimals. So 35.7% is 0.357. 108.1%, ignore this for now, because we just use that to do the work. It's 108.1% is equal to 1.081. 0.5 is 0.5. 13 over 93 is 0.138. And 1 and 7 68ths is 1.10, and it'll keep going on. So what's the smallest? So the smallest is the smallest is right here. So this is, I'm going to rank them from smallest to largest. So the smallest is 0.138. And the next largest is going to be 0.357, right?
0.5.
Then the next largest is going to be 0.5.
Then the 1.0.
Then you're going to have 1.08.
And then the 1.
Then you're going to have 1 and 7 68ths.
That's the largest.
So hopefully, well, actually, I'm going to do more examples of this. But for this video, I think this is the only one I have time for. But hopefully this gives you a sense of doing these problems. I always find it easier to go into the decimal mode to compare. And actually, the hints on the module do the same for you. But I think you're ready at least now to try the problems. If you're not, if you want to see other examples, you might just want to either rewatch this video or I might record some more videos with more examples right now. Anyway, have fun.
seems like already it's shouldn't simplified. It's ending with 7. Yo, I don't know. What am I supposed to say? Like that? Yo, okay. I'm pretty sure this. I'm gonna put 7 over to that thing. They're fraction simplest form. What the fuck is their common common factor? This is by 5, this is by 4, this is by 2. Let's see, 3, no. I think this wants me to write it in mixed number. Okay. Fractions percents. Four. 25. I guess so. Oh shit! 25 times 7. 75%. The numerator by the denominator. Okay, cool. I'm gonna do the activities, but I'm gonna take a few minutes break. What the hell? I'm back. My hair, oh my gosh, my hair sucks. I need a haircut, but I can't because of quarantine bullshit lockdown. Oh my god, it's so puffy and bullshit. I don't know anymore. I don't know anymore. Mary, really? My god, I've been recording for 50 minutes only. What the fuck? What? %20 of a number is what fraction of that number is. It's supposed to be 0.26. I don't know. Oh, by fraction. Okay. Oh, okay. I need to simplify bullshit. Okay. 1350. What fraction of is going to? Okay. Simplify bullshit again. Okay, 450. Oh, 4/5. So I guess it's 1150. Oh fuck. Yo, oh my gosh. Why did they write 50? If I did by 10, it's 11, and the other one's gonna be by 20, right? Oh my gosh, I wrote 1150. Pure stupidity. This is not right? What the fuck? Oh, I can't do mixed numbers? Kidding me? Something like that? 11 over 10? Fucking kidding me? I can't do mixed numbers, bitch. Oh my god. Divided by 4. 1/25. 8 for 100, or 4 to 100, or I guess 21 over. Oh shit, and 5. Cool. I'm so bored that I didn't even check if my answer is correct. It's divisible by 4. So 100, it's not divisible. Oh, okay. So I have like 6 and 5. Please work. Cool. Yo, I think we can simplify this. 5/12. Can divide this by 5, so I got 20 over here. This is like 13. 100 or 720. Cool. Fractions to percent. 36. That's very fast. Okay, cool. Quiz number 3. Okay, so 86 over 100. Then we're gonna simplify this bullshit. So divide that by 2. Now 43 over 50. as percent. It's 88%. This is 44. But I guess it wants to simplified, so 1125. Decimals like express a percent as a decimal. What percent of, okay. 186%. Yeah, it's definitely 6. 5 times 5 is 25. We have 9, 10, 11. Whoa, this is hard. What the fuck? 5 times 5, 25. 9, 10, 11. Oh my gosh, I could be wrong. Let's double check. I don't want to make a mistake here because, you know, things would just reset. Four, and then you get 100, 10, 4. Okay, 44% seems cool. Cool. How full is Naomi's oxygen tank in percent? Oh, the 60%, bro. Cool. Okay. Let's do percent pro. Oh my god, I hate this. Percent problems, percent word problems. I hate word problems. And look at that. Look at that videos. That's insane amount of videos. Oh my gosh. Is this the last part? I believe not. Oh my god, we still have these. Oh no. Okay. Okay, this is hard.
Let's give ourselves a little bit of practice with percentages. So let's ask ourselves, what percent of, I don't know, let's say what percent of 16 is 4? And I encourage you to pause this video and to try it out yourself. So when you're saying what percent of 16 is 4, percent is another way of saying what fraction of 16 is 4, and we just need to write it as a percent, as per 100. So if you said what fraction of 4 is, or what fraction of 16 is 4, you would say, well, look, this is the same thing as 4/16, which is the same thing as this is the same thing as 1/4. But this is saying what fraction 4 is of 16. You'd say, well, 4 is 1/4 of 16. But this still doesn't answer our question. What percent? What percent? So in order to write this as a percent, we literally have to write it as something over 100. Percent literally means per cent. The word cent, you know from cents and century. It relates to the number 100. So it's per 100. So you could say, well, this is going to be equal to question mark over 100, the part of 100. And there's a bunch of ways that you could think about this. You could say, well, look, if in the denominator to go from 4 to 100, I have to multiply by 25. In the numerator, to go from, I need to also multiply by 25 in order to have an equivalent fraction. So I'm also going to multiply by 25. So 1/4 is the same thing as 25 over 100. And another way of saying 25 over 100 is this is 25 per 100, or 25%. So this is equal to 25%. Now there's a couple of other ways you could have thought about it. You could have said You could have said, well, 4 over 16, this is literally 4 divided by 16. Well, let me just do the division and convert to a decimal, which is very easy to convert to a percentage. So let's try to actually do this division right over here. So we're going to literally divide 4 by 16. Now, 16 goes into 4 0 times. 0 times 16 is 0. You subtract and you get a 4. And we're not satisfied just having this remainder. We want to keep adding zeros to figure out what to get a decimal answer right over here. So let's put a decimal right over here. We're going into the tenths place. And let's throw some zeros right over here. The decimal, make sure we keep track of the fact that we are now in the tenths and then the hundredths and then the thousandths place if we have to go that far. But let's bring another 0 down. 16 goes into 40. Goes into 42 times. 2 times 16 is 32. You subtract, you get 8. And you could bring down another 0. And we have 16 goes into 80. Let's see, 16 goes into 80 5 times. 5 times 16 is 80. You subtract, you have no remainder, and you're done. 4 16ths is the same thing as 0.25. Now, 0.25 is the same thing as 25 hundredths. Or, this is the same thing as 25 over 100, which is the same thing as 25%. Let's see if we can figure out what 30% of 6 is. So one way of thinking about 30%, this literally means 30 per 100. So you could view this as 30 over 100 times 6 is the same thing as 30% of 6. Or you could view this as 30 hundredths times 6. So 0.30 times 6. And we could solve both of these, and you'll see that we'll get the same answer. If you do this multiplication right over here, 30 over 100, and you could view this times 6 over 1, this is equal to 180 over 100. And let's see, we can simplify. We can divide the numerator and the denominator by 10, and then we can divide the numerator and the denominator by 2, and we will get 9/5, which is the same thing as 1 4/5. And then if we wanted to write this as a decimal, 4/5 is 0.8. And if you want to verify that, you could verify that 5 goes into 4, and it's going to be a decimal, so let's throw some decimals in there. It goes into 4 0 times. We don't have to worry about that. It goes into 40 8 times. 8 times 5 is 40. Subtract, you have no remainder, and you just have zeros left here. So 4/5 is 0.8. You got the 1 there. This is the same thing as 1.8, which you would have gotten if you divided 5 into 9. You would have gotten 1.8. So 30% of 6 is equal to 1.8. And we can verify it doing this way as well. So if we were to multiply 0.30 times 6, let's do that. And I could just write that literally as 0.3 times 6 times 6. Well, 3 times 6 is 18. I have only one digit behind the decimal amongst both of these numbers that I'm multiplying. I only have the 3 to the right of the decimal, so I'm only going to have one number to the right of the decimal here. So I'll just count one number. It's going to be 1.8. So either way you think about it or calculate it, 30% of 6 is 1.8.
We're asked to identify the percent, amount, and base in this problem. And they ask us, 150 is 25% of what number? So another way to think about it is 25% times some number. So I'll do 25% in yellow, and 25% times some number times some number is equal to 150. So the percent is pretty easy to spot. We have a 25% right over here. So this is going to be the percent. That is the percent. And we're multiplying the percent times some base number. So this right over here is the base. So we have the percent times the base. We have the percent times the base is equal to some amount. Is equal to some is equal to some amount. And you could try to solve this in your head. This is essentially saying 25% of some number, 25% times some number is equal to 150. If it helps, we could rewrite this as 0.25, which is the same thing as 25%. 0.25 times some number is equal to 150. And one interesting thing is just think about, should that number be larger or smaller than 150?
Larger.
Well, if we only take 25% of that number, if we only take 25 hundredths of that number, if we only take 1/4 of that number, because that's what 25 hundredths is, or that's what 25% is, we get 150. So this number needs to be larger than 150. In fact, it has to be larger than 150 by 4. And to actually figure out what the number is, we can actually multiply. Since what's on the left-hand side is equal to the right-hand side, if we want to solve this, we can multiply both sides by 4. If we say, look, we have some value over here, we're going to multiply it by 4. In order for it to still be equal, we have to multiply 150 times 4. 4 times 0.25, or 4 times 25%, or 4 times 1/4, this is just going to be 1. That is just going to be 1. And we're going to get our number is equal to 150 times 4, or it is equal to 600. And that makes sense. 25% of 600 is 150. 1/4 of 600 is 150. 100 is what percent of 80? And these problems tend to kill people because on some level they're kind of simple. There's just 100 and an 80 there, and they're asking what percent. But then people get confused. They say, do I divide the 100 by the 80 by 100, or is it something else going on? And you really just have to think through what the language is saying. They're saying that this value right here, this 100, is some percentage of 80. And that some percentage is what we have to figure out. That what percent. So if we multiply 80 by this what percent, we will get 100. So let's view it this way. We have 80. We have 80. If we multiply it by something, let's call this something x. If we multiply, let me do that in a different color. If we multiply 80 by something, we're going to get 100. And we need to figure out what we need to multiply 80 by to get 100. And if we just solve this equation as it is, we're going to get a value for x. And what we need to do is then convert it to a percent. Another way you could view this is, 100 is what you get when you multiply what by 80. And then you would have gotten this number, and then you could convert it to a percent. So this is essentially the equation, and now we can solve it. If we divide both sides of this equation by 80, so you divide the left-hand side by 80, the right-hand side by 80, you get x. X is equal to 100 over 80. You could divide, they both share a common factor of 20. So 100 divided by 20 is 5, and 80 divided by 20 is 4. So in simplest form, x is equal to 5/4, but I've only expressed it as a fraction. But they want to know what percent of 80. If they just said 100 is what fraction of 80, we would be done. We could say 100 is 5/4 of 80. And we would be absolutely correct. But they want to say what percent. So we have to convert this to a percent. To be absolute fraction of 80, we would be done. We could say 100 is 5/4 of 80, and we would be absolutely correct. But they want to say what percent. So we have to convert this to a percent. And the easiest thing to do is to first convert it into a decimal. So let's do that. 5 over 4 is literally the same thing as 5 divided by 4. So let's figure out what that is. Let me do it in magenta. So 5 divided by 4. 5 divided by 4, and we want to have all the decimals there, so let's put some zeros out here. 4 goes into 5 one time. Let me switch up the colors. One time. 1 times 4 is 4. You subtract. You get 5 minus 4 is 1. Bring down the next 0. And of course, the decimal is sitting right here, so we want to put it right over there. So you bring down the next 0. You bring down the next 0. 4 goes into 10 2 times. 2 times 4 is 8. You subtract. 10 minus 8 is 2. Bring down the next 0. Bring down the next 0. 4 goes into 20 5 times. 5 times 4 is 20. Subtract no remainder. So this is equal to 1.25. 5 over 4 is the same thing as 5 divided by 4, which is equal to 1.25. So far we could say 100 is 1.25 times 80, or 1.25 of 80. You could even say it, but we still haven't expressed it as a percentage. This is really just as a number, I guess you could call it as a decimal, but it's a whole number and a decimal. It would be a mixed number if we didn't do it as a decimal. It's 1 and 1/4, or 1 and 25 hundredths, however you want to read it. So to write it as a percent, you literally just have to multiply this times 100, or shift the decimal over twice. So this is going to be equal to, as a percent, if you just shift the decimal over twice, this is equal to 125 percent. Let me not write it out. 125%. And that makes complete sense. 100 is 125% of 80. 80 is 100% of 80. 100% is more than 80. It's actually 1 and 1/4 of 80. And you see that right over there. So it makes sense that it's 125%. It's more than 100%. But we are done. We've solved the problem. It is 125% of 80.
Oh shit. Oh, three answers. Uh, okay. Wait. This is hard. 20, 75x is equals 21, right? So we're just really going to divide 21 by 75, dude. I mean, why is this fucking up my brain? Do we have 150? 160? We have 600? Let's see. So this is by 8, right? Then, so 75 times 8, 44, 56, 600. Okay, cool. 0.28, 28. 15 is what percent of 25? Uh, 15 is what percent of wait, what? I'm confused. 15 is what percent of 25? We have 25 divided by 15. 10, 100. So I think if I do 8, 44 plus 120, let's do 15 times 6, 30, 90. Okay, so 6 get 90, 10, and we're in a feedback loop. 1.6. Okay, it's insane. 15 is maybe it's 25x, right? So it should be like 15 divided by 25, not the other way around. So it's 4, 6. 80% of 25. Zero, 400, 0, 16, 0, 10, 200, 20. It's 25% of 4. I think I don't need to calculate this. I know that this should do 4. 1/6 what percent of 200? 162 is what percent of 200? Uh, 162 is what percent of 200? Okay, so this is 200. Let's see. If it's 10, let's see, by 8. If we do 200 by 8, 1/6, right? So 8. Oh, 1. 1%. It's gonna be 80, right?
$78 is 15% of what number? So there's some unknown number out there, and if we take 15% of that number, we will get 78. So let's just call that unknown number x. And we know that if we take 15% of x, so if we take 15% of x, so multiply x by 15%, we will get we will get 78. And now we just literally have to solve for x. Now, 15% mathematically, you can deal directly with percentages, but it's much easier if it's written as a decimal. And we know that 15% is the same thing as 15 per 100. That's literally per cent. Cent means 100, which is the same thing as 0.15. This is literally 15 hundredths. 15 hundredths. So we could rewrite this as 0.15 times some unknown number times x is equal to 78. And now we can divide both sides of this equation by 0.15 to solve for x. So you divide the left side by 0.15. And I'm literally picking 0.15 to divide both sides.
Oh, wait, check. Oh, why? Oh my god. 15, 78, 5, 75, 3, 2. 52.
Because that's what I have out here in front of the x. So if I'm multiplying something by 0.15 and then I divide it by 0.15, I'll just be left with an x here. That's the whole motivation.
What? Doesn't make sense. Okay. So if we have like 78 divided by 15, but then of course it's by percent, so I guess I'm gonna move it like the pass. No, it's 20,200 though. Okay, let's try this. It's gonna be 5. 5, 75. 5 times 5, 75, right? 5, 15 times 5, 25. 2, 5, 75. So we got then 3 left over. 3, then 30. For 20, we need like 2 of them. So 30, 0. Then this is by percent. Wait, comes to 100. Wait, what? 520.
If I do it to the left-hand side, I have to do it to the right-hand side.
0.520.
0.15. These cancel out, and I get x. X is equal to 78 divided by 0.15. Now, we have to figure that out, what that is. We got a calculator, pretty straightforward, but let's actually work it out. So we have 78 divided by, and it's gonna be some decimal number. So it's going to be some decimal number. It's going to be larger than 78, but let's figure out what it ends up being. So let's throw some zeros out there. It's not going to be a whole number, and we're dividing it by 0.15. 0.15. Now, so to simplify things, let's multiply both this numerator and this denominator by 100, and that's so that 0.15 becomes 15. So 0.15 times 100 is 15. We're just moving the decimal 2 to the right. Let me put that in a new color. Right there, that's where our decimal goes, and let me erase the other one so we don't get confused. And if we did that for the 15, we also have to do that for the 78. So if we move the decimal 2 to the right, 1, 2, it becomes 7,800. 7,800, or 7,800. So one way to think about it, 78 divided by 0.15 is the same thing as 7,800 divided by 15, multiplying the numerator and the denominator by 100. So let's figure out what this is. 15 does not go into 7. 15, so you could do 0 times and you could do all of that, or you could just say, okay, that's not going to give us anything. So then how many times does 15 go into 78? So let's think about it. 15 goes into 64 times. It'll go, 15 times 5 is 75. That looks about right. So we say 5 times. 5 times 15, 5 times 5 is 25. Put the 2 up there. 5 times 1 is 5, plus 2 is 7. 75, you subtract. 78 minus 75 is 3. Bring down a 0. Bring down a 0. 15 goes into 30, exactly 2 times. 2 times 15 is 30. Subtract, no remainder. Bring down the next 0. We're still to the left of the decimal point. The decimal point is right over here. If we write it up here, which we should, it's right over there. So we have one more place to go. So we bring down this next 0. 15 goes into 0. 0 times 15 is 0. Subtract. No remainder. So 78 divided by 0.15 is exactly 520. So x is equal to 520. So 78 is 15% of 520. And if we want to use some of the terminology that you might see in a math class, the 15% is obviously the percent. This is the percent. That is the percent. 520, or the what number before we figured out it was 520, that's what we're taking the percentage of. This is sometimes referred to as the base. That is the base. And then when you take some percentage of the base, you get what's sometimes referred to as the amount. So in this circumstance, 78 would be the amount. You could view it as the amount is the percentage of the base, but we were able to figure that out. It's nice to know those. If that's the terminology used in your class. But the important thing is to be able to just answer this question. And it makes sense, because 15% is a very small fraction. So 78 is a small percentage. If 78 is a small percentage of some number, that means that number has to be pretty big. It has to be pretty big, and our answer gels with that. This looks about right. 78 is about 15% of, or it is exactly 15% of 520.
Oh, guavas.
Let's say I go to the fruit store today and they have a sale on guavas. Everything is 30% off. This is for guavas. On guavas, and it's only today. Only today. So I say, you know what? Let me go buy a bunch of guavas. So I go and I buy 6 guavas. So I buy 6 guavas. And it ends up when I go to the register, and we're assuming no tax for, it's a grocery, and I live in a state where they don't tax groceries. So for the 6 guavas, they charge me, I get the 30% off, they charge me $12.60. $12.60. So this is the 30% off sale price on 6 guavas. I go home, and then my wife tells me, Sal, can you go get 2 more guavas tomorrow? I say, sure. So the next day I go and I want to buy 2 more guavas. So 2 guavas. But now the sale is off. There's no more 30%. That was only that first day that I bought the 6. So how much are those 2 guavas going to cost me? How much are those 2 guavas going to cost at full price? At full price. So a good place to start is to think about how much would those 6 guavas cost us at full price. This is the sale price right here. This is the sale price. How much would those have cost me at full price? So let's do a little bit of algebra here. Let me pick a suitable color for the algebra. Oh, maybe this is gray color. So let's say that x is equal to the cost of 6 guavas, at full price. So essentially, if we take 30% off of this, we should get $12.60. So let's do that. So if we have the full price of 6 guavas, we're going to take 30% off of that. So that's the same thing as 0.30, or I could just write 0.3. I could ignore that 0 if I like. Actually, let me write it like this. My wife is always bugging me to write zeros before decimals. So that's the full price of 6 guavas minus 0.30 times the full price of guavas. So I'm literally just taking 30% off of the full price off of the full price. This is how we figure out the sale price. This is going to be equal to that $12.60 right there. That's going to be equal to $12.60. I just took 30% off of the full price. And now we just do algebra. We could imagine there's a 1 in front. X is the same thing as 1x. So 1x minus 0.3x is going to be equal to 0.7x. So we get 0.7x. We can say 0.7 if you like, same number. 0.7x is equal to 1260. And once you get used to these problems, you might just skip straight to this step right here. Well, you say, hey, 70% of the full price is equal to my sale price, right? I took 30% off. This is 70% of the full price. You might just skip to this step once you get used to these problems a little bit. And now we just have to solve for x. Divide both sides by 0.7. So you get x is equal to 1260 divided by 0.7. We could use a calculator, but it's always good to get a little bit of practice dividing decimals. So let's do that. So we get 0.7 goes into 1260. Let's multiply both of these numbers by 10, which is what we do when we move both of their decimals one to the right.
Wow,
So
18.
the 0.7 becomes a 7.
X
Ignore
is
that
equal
right
to
there.
18.
The 1260 becomes 126. Put the decimal right there. Decimal
That's
right
for
there.
6 guavas.
And we're ready to just do straight up long division.
So it's
So
divided by
this is
6.
now a 7, not a 0.7. So 7 goes into 12 one time. 1 times 7 is
$3.
7.
Then
12 minus 7 is
$6
5.
for the
Bring down the 6. 7 goes into 56 8 times. 8 times
2
7
guavas gonna
is
cost us
56.
$6, I guess.
And then we have no remainder. So it's 18, and there's nothing behind the decimal point. So it's 18, in our case, $18. So x is equal to $18. Remember what x was? X was the full price of 6 guavas. X was the full price of 6, did I say avocados? X is the full price of 6 guavas. Now, the question is, how much will 2 guavas cost me the full price? Well, this is full price of 6. So you immediately could figure out what's the full price of 1 guava. You divide 18 by 6. So 18 divided by 6 is $3. That's $3 per guava at full price. And they're asking us, we want 2 guavas. So 2 guavas is going to be 2 times $3. So this is going to be $6. $6. Another way you could have done it, you could have just said, hey, 6 at full price are going to cost me $18. 2 is 1/3 of 6, so 1/3 of $18 is $6. So just to give a quick review of what we did, we said the sale price on 6 guavas, $12.60. That's 30% off the full price. Or you could say this is 70% of the full price. 70% of the full price. And so you could say 30%. So if you say x is the full price of 6 guavas, you could say the full price of 6 guavas minus 30% of the full price of 6 guavas is equal to $12.60. And that's equivalent to saying 70% of the full price is $12.60. You divided, and we just solved this algebraically, divide both sides by 0.7, and then we got x, the full price of 6 guavas, is $18, or that's $3 per guava, or $6 for 2. Anyway, hopefully you found that helpful.
Amazing.
Let's say I go to the fruit store today and they have a sale on guavas. Everything is 30% price at full price. So
In the United States, 13 out of every 20 cans are recycled. What percent of cans are recycled? So 13 out of every 20 are recycled. So 13 20ths, or 13 over 20, could also be viewed as 13 divided by 20, or 13 divided by 20. And if we do this, we'll get a decimal, and it's fairly straightforward to convert that decimal into a percentage. So 13 divided by 20, we have the smaller number, in this case, being divided by the larger number. So we're going to get a value less than 1. Since we're going to get a value less than 1, let's put a decimal right over here, and let's add a couple of zeros, as many zeros as we would need. And we could say, hey, look, 20 goes into 13 0 times 20 is 0, and then 13 minus 0 is 13. Now you bring down a 0. 20 goes into 130. Let's see, it goes in 5 times 20 is 100, so 6 times 20 is 120. So it's going to go 6 times. 6 times 20 is 120. You subtract, you get a 10. Let's bring down another 0. 20 goes into 100 5 times. 5 times 20 is 100, and we are done. So this written as a decimal, is 0.65. So as a decimal, it's 0.65. And if you want to write it as a percentage, you essentially multiply this by 100. Or another way you could say is you shift the decimal over 2 spots to the right. So this is going to be equal to 65%. Now, there's another way you could have done it, is you could have said, look, percent literally means per 100. So 13 out of 20 is going to be equal to what over, is going to be equal to what over 100? Well, to go from 20 to 100, you forget the denominator. To go from 20 to 100, you would multiply by 5. So let's multiply the numerator by 5 as well. And 13 times 5, let's see, that's 15 plus 50, which is 65. So this would have been a little bit of a faster way to do it, especially if you recognize it's pretty easy to go from 20 to 100. You multiply by 5. So we would do the same thing with the 13. And so you'd get 65 over 100, which is the same thing as 65 per, let me write this percent symbol, 65%. And just a reminder, percent literally means per 100. 65 per 100, 65%.
I need to go to the bathroom. Gonna pause this. I'm back. Go.
A zoo has 15 emperor penguins who make up 30% of the total number of penguins at the zoo. How many penguins live at the zoo? So let's let x equal the number of the total number of penguins who live at the zoo.
Okay, so 15% are emperor penguins.
So they're telling us that 30% of that are the emperor penguins, which are 15. So they're saying if we take 30%, so 30% of x is equal to 15. Or another way of saying this is we could say, instead of writing 30%, we could write that as a decimal as 0.30 of x. So 0.30 times x is equal to 15. And now to solve this, we just have to divide 0.3, or we have to divide both sides by 0.30. Let's do that. 0.30. We get x is equal to 15 divided by 0.30. Now that's, let's do a little, we're going to have to do a little arithmetic to solve this one. So if you take 0, it's 15 divided by 0.30. So just as a refresher of dividing decimals, we can essentially multiply both of these by 100. And when you multiply both of them by 100, you can't just multiply one of them, then you would get a different answer. But if you multiply both of them by 100, you move this decimal over 2 spots, so it becomes a 30. And you move this decimal over 2 spots, so it becomes 1500. So it really boils down to how many times, the same number of times that 30 goes into 1500 is the number of times that 0.30 will go into 15. So let's think about this. Let me rewrite it here just so it's neat. 30 goes into 1500. All we did is we moved both decimals over to the right twice. Or you could say we just multiplied the numerator and the denominator here by 100, which wouldn't change the value of the fraction. So 30 goes into, let's see, it doesn't go into 1, doesn't go into 15. It does go into 150. It goes into 150 5 times. 5 times 30 is 150. Subtract, you get a 0, and then 30 goes into 0 times. So this 30 goes into 1500 50 times. So this right over here is equal is equal to
There are
50.
50 penguins.
And you can verify it. Multiply 0.3 times 50 and you will get 15.
15. Ah, yeah.
Now, there is another way of doing it. You could say the fraction of emperor penguins over the total number of penguins at the zoo. So you could say 15. You could say 15 over the total number of penguins at the zoo is equal to 30%. Percent literally means 30 hundredths. So it's equal to 30 for every 100. It's equal to 30 for every 100. And then you could solve for this right over here. And a really simple way of doing this is you say, look, to go from 30 to 15, you have to divide by 2 if you're going from the right to the left. So let's divide by 2 right over here. So x would be equal to 50. 15 over 50 is the same thing as 30 over 100. So the total number of penguins are 50.
Cool.
Let's do some more percentage problems. Let's say that I start this year in my stock portfolio with $95. And I say that my portfolio grows by, let's say, 15%. How much do I have now?
Does the year even matter?
Have now. Okay, I think you might be able to figure this out on your own, but of course we'll do some example problems just in case it's a little confusing. So I'm starting with $95, and I'll get rid of the dollar sign. We know we're working with dollars. $95, right? And I'm going to earn, or I'm going to grow, just because I was an excellent stock investor. That $95 is going to grow by 15%. So to that $95, I'm going to add another 15% of 95. So we know we write 15% as a decimal as 0.15.
15.
So 95 plus 0.15 of 95 times 95. That dot is just a time sign.
That's right.
It's not a
I
decimal.
got 109.25.
It's a little higher than a decimal. So 95 plus 0.15 times 95 is what we have now, right? Because we started with $95, and then we made another 15% times what we started with. Hopefully that makes sense. Another way we say it, the $95 has grown by 15%. So let's just work this out. This is the same thing as 95 plus, well, what's 0.15 times 95? Let's see. So let me do it. Hopefully I have enough space here. 95 times 0.15. I don't want to run out of space.
Sal,
Let me do it up here. I think I'm about to run out of space. 95
You just erased it.
times 0.15. 5 times 5 is 25.
So
9
ancient, like
times 5 is
2007 era.
45. Plus 2 is 47. 1 times 95 is 95.
95.
Bring down the 5. 12. Carry the
14.
1. 15.
14. 25.
And how many decimals do we have?
Holy
1,
shit.
15.25. Gee, is that right?
No,
I think
it's
I made a mistake
14.
here. See. 5 times 5 is 25. 5 times 9
That's so
is
surprising.
45. Plus 2 is 47. We bring a 0 here. It's 95. Right? 1 times 5, 1 times 9. And then we add 5 plus 0 is 5. 7 plus 5 is 12. Oh, see, I made a mistake. It's 14.25, not 15.25.
True.
So I'll ask you an interesting question. How did I know that 15.25 was a mistake? Well, I did a reality check. I said, well, I know in my head that 15% of 100 is 15. So if 15% of 100 is 15, how can 15% of 95 be more than 15? I think that might have made sense. The bottom line is 95 is less than 100. So 15% of 95 had to be less than 15. So I knew my answer, 15.25, was wrong. And so it turns out that I actually made an addition error, and the answer is 14.25. So the answer is going to be 95 plus 15% of 95, which is the same thing as 95 plus 14.25. So 95
plus 14.25. Well, that equals what? 109.25. 109.25. Notice how easy I made this for you to read, especially this 2 here. 109.25. So if I start off with $95 and my portfolio grows, or the amount of money I have grows by 15%, I'll end up with $109.25. Let's do another problem. Let's say I start off with some amount of money, and after a year, let's see, my portfolio grows.
This time?
My portfolio grows 25%, and after growing 25%, I now have let's say I now have $100. How much did I originally have? Notice, I'm not saying that the $100 is growing by 25%.
Yeah.
I'm saying that I start with some amount of money.
Wow.
It grows by 25%, and I end up with $100 after it grew by 25%. To solve this one, we might have to break out a little bit of algebra. So let x equal what I start with. What I start with. So just like the last problem, I start with x, and it grows by 25%. So x plus 25% of x is equal to 100. And we know this 25% of x we can just rewrite as x plus 0.25 of x is equal to 100. And now actually we have a level, actually this might be a level 3 system, level 3 linear equation. But the bottom line, we can just add the coefficients on the x.
What's up with level 3 stuff?
A level, actually this might be a level 3 system, level 3 linear equation. But the bottom line, we can just add the coefficients on the x. So here x is the same thing as 1x, right? So 1x plus 0.25x, well that's just the same thing as 1 plus 0.25x. We're just doing the distributive property in reverse. Equals 100. And what's 1 plus 0.25? That's easy. It's 1.25. So you say 1.25x is equal to 100. Not too hard. And after you do a lot of these problems, you're going to intuitively say, oh, if some number grows by 25% and it becomes 100, that means that 1.25 times that number is equal to 100. And if this doesn't make sense, sit and think about it a little bit. Maybe rewatch the video and
It's just 40?
and hopefully it'll over time. It becomes 100. Not too hard. And after you do a lot of these problems, you're going to intuitively say, oh, if some number grows by 25% and it becomes 100, that means that 1.25 times that number is equal to 100. And if this doesn't make sense, sit and think about it a little bit. Maybe rewatch the video, and hopefully it'll over time start to make a lot of sense to you. And this type of math is very, very useful. I work at a hedge fund, and I'm doing this type of math in my head day and night. So 1.2 at a hedge fund, and I'm doing this type of math in my head day and night. So 1.25 times x is equal to 100. So x would equal 100 divided by 1.25. I just realized you probably don't know what a hedge fund is. I invest in stocks for a living. Anyway, back to the math. So x is equal to 100 divided by 1.25. So let me make some space.
I got 40. It doesn't make sense though.
Just because I used up too much space. Let me get rid of my let x statement. Actually, I think we...
Oh, why did I... Oh,
what
fuck.
x is.
AD.
You know how we got to
my
the,
god.
there. If you forgot how we got there, you can, I guess, rewatch the video.
Alright, I got 8.
Let's see. Now let me make the pen
Yeah, it makes
thin
sense.
again.
25% 80.
And go back to the
20.
orange color.
So 8 plus 20 is going to be 100.
Okay, x equals 100 divided by 1.25. So we say 1.25 goes into 100.00. I'm going to add a couple of zeros. I don't know how many I'm going to need. Probably added too many. If I move this decimal over 2 to the right, I need to move this one over 2 to the right. right? And I say, well, how many times does 100 go into 100? How many times does 125 go into 100? None. How many times does it go into 1,000? It goes into it 8 times. I happen to do that in my head, but you can do trial and error and think about it. 8 times, if you want to think about it, 8 times 100 is 800, and 8 times 25 is 200, so it becomes 1,000. You can work it out if you like, but I think I'm running out of time, so I'm going to do this fast. 8 times 125 is 1,000. Remember, this thing isn't here. 1,000. So 1,000 minus 1,000 is 0. So you can bring down the 0. 125 goes into 0 0 times. And we just keep getting zeros. This is just a decimal division problem. So it turns out that if your portfolio grew by 25% and you ended up with $100, you started with $80. And that makes sense, because 25% is roughly 1/4, right? So if I start with $80 and I grow by 1/4, and that makes with $100, you started with $80. And that makes sense, because 25% is roughly 1/4.
Roughly 1/4.
Fourth, right? So if I start with $80 and I grow by 1/4, that means I grew by $20, because 25% of 80 is 20. So if I start with 80 and I grow by 20, that gets me to 100. Makes sense. So remember, all you have to say is, well, some number times 1.25, because I'm growing it by 25%, is equal to 100. Don't worry, if you're still confused, I'm going to add at least one more presentation on a couple of more examples like this.
Holy shit, it's a lot of video. Let's give 6 more videos? Oh my god, this is insane.
We're asked to identify the percent, amount, and base in this problem. And they ask us, 150 is 25% of what number? They don't ask us to solve it, but it's too tempting. So what I want to do is first answer this question that they're not even
already solved this. This is 600.
asking us to solve. But first I want to answer this question, and then we can think about what the percent, the amount, and the base is. Because those are just words, those are just definitions. The important thing is to be able to solve a problem like this. So they're saying 150. They're saying 150 is 25% of what number? Or another way to view it is 150 is 25% of some number. So let's, if we say that x, so let's let x is equal to the number that 150 is 25% of. Right? That's what we need to figure out. 150 is 25% of what number? That number right here we're saying is x. So that tells us that if we start with x, and if we were to take 25% of...
Okay, let's see. 25% of what number? 25%, so it's 0.25x equals 1/5. So 150 divided by 25. You can double that. Okay, cool.
Of x. If we were to take 25% of x, so 25% of x, you can imagine that's the same thing as multiplying it by 25%, which is the same thing as multiplying it, if you view it as a decimal, times 0.25 times x. These two statements are identical, so if you start with that number, you take 25% of it, or you multiply it by 0.25, that is going to be equal to 150. That is going to be equal to 150. 150 is 25% of this number. And then you can solve for x. So let's just start with this one over here. So if we just have, let me just write it separately so you understand what I'm doing. 0.25 times some number is equal to 150. Now, there's two ways we can do this. We can divide both sides of this equation by 0.25, or if you recognize that, well, 4 quarters make $1, you could say, let's multiply both sides of this equation by 4. You could do either one. I'll do the first, because that's how we normally do algebra problems like this. But so let's just multiply both by 0.25, multiply this times, or multiply by 0.25, that will just be an x, and then the right-hand side will be 150 divided by 0.25. And the reason why I want to do this is really just good practice dividing by a decimal. So let's do that. So we want to figure out what 150 divided by 0.25 is. And we've done this before. When you divide by decimal, what you can do is you can make the number that you're dividing into the other number, you can turn this into a whole number by essentially shifting the decimal 2 to the right. But if you do that for the number in the denominator, you also have to do that to the numerator. So right now, you can do this as 150.00. If you multiply 0.25 times 100, you're shifting the decimal 2 to the right. Then you'd also have to do that with 150, so then it becomes 15,000. Shift it 2 to the right. So our decimal place becomes like this. So 150 divided by 0.25 is the same thing as 15,000 divided by 25. And let's just work it out really fast. So 25 doesn't go into 1, doesn't go into 15. It goes into 150. What is that? 6 times, right? It goes into 104 times. It goes into 150 6 times. 6 times 0.25 is, or actually this is now a 25. We've shifted the decimal. The decimal is sitting right over there. So 6 times 25 is 150. You subtract, you get no remainder. Bring down this 0 right here. 25 goes into 0, 0 times. 0 times 25 is 0. Subtract, no remainder. Bring down this last 0. 25 goes into 0, 0 times. 0 times 25 is 0. Subtract, no remainder. So 150 divided by 0.25 is equal to 600. And you might have been able to do that in your head, because when we were at this point in our equation, 0.25x is equal to 150, you could have just multiplied both sides of this equation times 4. 4 times 0.25 is the same thing as 4 times 1/4, which is a whole, and 4 times 150 is 600. So you would have gotten it either way. And this makes total sense, because if 150 is 25% of some number, that means 150 should be 1/4 of that number. It should be a lot smaller than that number, and it is. 150 is 1/4 of 600. Now, let's answer their actual question. Identify the percent. Identify the percent. Well, it looks like 25%. That's the percent, is 25%. The amount and the base in this problem. And based on how they're wording it, I assume amount means when you take the 25% of the base. So they're saying that the amount, is my best sense of it, is that the amount is equal to the percent, times the base. Times the base. Let me do the base in green. So the base is the number you're taking the percent of. The amount is the quantity that percentage represents. So here we already saw the percent. The percent is 25%. That's the percent. The number that we're taking 25% of, or the base, is x. You know, this right here, what number? X. That is the base. The value of it is 600. We figured it out. And the amount is 150. This right here is the amount. The amount is 150. 150 is 25% of the base of 600. The important thing is, how do you solve this problem? You know, the words themselves, you know, those are all really just definitions.
In a video game, Val scored 30% fewer points than PETA. PETA scored 1,060 points. How many points did Val score? Pause this video and see if you can figure out how many points Val scored.
Okay, I'm gonna figure out. So we're looking for, well, so 30% his points, so it's gonna be like 1060, 30, it's 0.3, 31, 2. Let's see, it's gonna be 3 times, and then 90, and 6, 16 over here, and 10, 6, yeah, 160, 5, 150, then 100. We got 3 again, 90, and holy shit. Oh, this is pure. Okay. So if so, x, we're gonna do 0.7. So 1060 divided by 0.7 or by 7, 10,000 is gonna divide by 7. So we have like 7, 3, 36, 5, 35, 1, 0, 1, 1, 7, 3, 30, 4, 4, 28. Whoa, this is insane. 20, 2, 0.2, 2 times 14, 6, 60. Oh, that's a lot. It's 8, 26, 40. Yo, my god, it's insane. 35, 35, and then 50, and then 7, 49, and then 1, 10, back to 1, 7, 3, 30, 4, 28, 20. Holy shit, this is insane.
All right, well, now let's do this together. There's a couple of ways that you could think about it. One way to think about it is Peter scored 1,060 points, and Val scored 30% fewer. When we're saying 30% fewer, we're saying essentially take 30% of 1060 and subtract that from 1060. So 30%, so that we could write that as a decimal, is 0.30. 30 hundredths is the same thing as 30%. Or we could even write this as 0.3. And then we would want 30% of 1060. So if you take P to score and then subtract 30% of P to score, then this would give you Val score. So that's one way to calculate it. Another way to think about it is, whatever you're starting with, let's call that 100%. And if you were to take out 30% of it, if you were to have 30% less, then you're going to have 70% of what you started with. So another way to think about it is we could take P to score of 1060 and multiply it by 70%. And multiplying it by 70% is the same thing as multiplying it by 0.70, which is the same thing as multiplying it by 70 hundredths is the same thing as 7 tenths. So let's just do this. So if I have 1060 and I multiply by 0.7, what do I get? 7 times 0 is 0, 7 times 6 is 42, 7 times 0 is 0, plus 4 is 4, 7 times 1 is 7, and I have one digit to the right of the decimal. So there you have it. It is 742. 742. That is how many points Val scored. Let's do another example. So we're told there are 20% more goblins than wizards in a magic club. There are 220 goblins and wizards all together in Magic Club. How many goblins are...
Wait. So it's, if we have like 0.7x equals... no, x is equals to that amount, and we're looking for like 70% of it. Just a sec. X and 6.
are in the Magic Club. So pause the video. 742. That is how many points Val scored. Let's do another example. So we're told there are 20% more goblins than wizards in a Magic Club. There are 220 goblins and wizards all together in Magic Club. How many goblins are in the Magic Club? So pause the video and see if you can work through this on your own.
There are 20% more goblins than wizards in Magic Club. Wow, this is hard. 20 altogether, then 20% more? Oh shit. I can't. Let's just work with South.
Your own. So this one is an interesting one. It's going to involve a little bit of algebra here. So what we want to do is, let's set a variable. Let's say W is the number of wizards. So that's the number of wizards. And then if we said G for goblins, let's say G for goblins, so W plus G is equal to 220. Is equal to 220. And you're like, well, how does that help me? How does that help me actually figure out how many goblins are in the Magic Club? I have two variables here with one equation. Well, one way to think about it is, remember, they give us more information. They tell us there are 20%, let me box that, there are 20% more goblins than wizards. So we also know one other thing. We know that the goblins are equal to the number of wizards plus 20%. So you could view this as wizards plus 20% of wizards. And I'm writing that as 20 hundredths, or you could even write that as 2/10 plus 2/10 times the number of wizards. Or another way of thinking about it, goblins are equal to, if I have one of something and then I have another 2/10 of that something, then I'm going to have 1.2 of that something. So goblins is equal to 1.2 times the wizards. And so we could use that to substitute back in here. And then we could say the number of wizards plus the number of goblins, which happens to be 20% more than the number of wizards, is going to be equal to 220. That is the same color.
That's insane, bro.
220. Now this is pretty straightforward to solve. What is W plus 1.2W? Well, that is going to be 2.2W. 2.2W. You could use this 1W plus 1.2W is 2.2W is equal to 220. And so just divide both sides. Let me scroll down a little bit. Divide both sides by 2.2. 2.2. And what do you get? You get W, the number of wizards, is equal to, let's see, this is going to be equal to 100. The number of wizards is equal to 100. Now, is that our answer? No, they're asking how many goblins are in the Magic Club. Well, we know that goblins are 1.2 times the wizards. So the number of goblins is going to be 1.2 times 100, which is equal to 120. So there's 120 goblins. And that makes sense. 120 is 20% more than 100. And if you add the 100 wizards to the 120 goblins, you get 220 goblins and wizards all together. Let's do another example. Here we're told Cody was 165 centimeters tall on the first day of school this year, which was 10% taller than he was on the first day of school last year. How tall was Cody on the first day of school last year? Pause this video, see if you can figure that out. So let's just define a variable here. Let's just say that his height on the first day of school last year, let's say that that is x. So his height on the first day of school last year is x. This year he is 10% taller. So we would add 10%, which we could say is 10 hundredths, or we could even say that as 1/10. He's 1/10 taller. So whatever his height was last year, we're going to add a tenth of that same height again, to get to his height this year, which they tell us is 165 centimeters. And so here we could say, well, 1x plus a tenth of an x is going to be 1 and 1/10 x is equal to 165. And now to solve for x, which remember was his height on the first day of school last year,
150.
we divide both sides by 1.1. And so x is equal to, well, let's see what this is going to be. If I were to take 165 divided by 1.1, the first thing I would want to do is multiply them both by 10, so that has the effect of moving this decimal place 1 to the right. So really, I am now trying to figure out what 11 goes into 1,650 is. And so let's see, let me just do that step by step. 11 goes into 16 one time. 1 times 11 is 11. Subtract. We get a 5, and we bring down a 5. 11 goes into 55 exactly 5 times. 5 times 11 is 55. Subtract. We have no remainder, but then we bring down this 0, and we do it one more time. 11 goes into 0 times. Remember, the decimal place is right over here. 0 times 11 is 0, and then we have no remainder. So last year, he was 150 centimeters. And it's always good to do a reality check. Make sure, for example, if I divided wrong and I somehow got 15 or I got 1,500, just to make sure that that wouldn't make any sense. 150 centimeters, you add 10% of that. 10% of 150 is 15 centimeters. So you add 10% of that, you indeed do get to 165 centimeters for the first day of school this year.
This is so cool.
In a video game, Val scored 30%.
This one is incorrect.
We're told that Casey buys a bracelet. She pays for the bracelet and pays 72 cents in sales tax. The sales tax rate is 6%. What is the original price of the bracelet before tax? So pause this video and see if you can figure this out.
Casey buys a bracelet. She pays for the bracelet and pays in the sales tax. I don't even know what is tax. How do they?
Well, let's think about how your sales tax is calculated. Your sales tax would be equal to the sales tax rate. I'll just call that the rate. So that's going to be equal to the rate times your original price. Original price. And what do we know here? Well, they tell us what our sales tax is. Our sales tax is 72 cents. So I'll write that here. So 72 cents is going to be equal to my sales tax rate. They also tell us that is 6%. Is going to be equal to 6% times my original price. And that's what they're asking for, the original price. So times, let's just call it P for short, original price. And so you have it. We have a fairly straightforward equation now. And now I'm just going to rewrite everything as a decimal. So we could write 0.72 is equal to 6% is the same thing as 6 per 100, which is the same thing as 6 hundredths. 0.06, 6 hundredths times P. And now we can just divide both sides by 6 hundredths to solve for the original price. So let's do that. All right. So on the right-hand side, I have a P. On the left-hand side, if I have 72 hundredths divided by 6 hundredths, Well, that's going to be equal to 12. 12 times 6 is 72. 6 hundredths times 12 would be 72 hundredths. And so this is going to be equal to 12. So the original price of the bracelet before tax is $12. And you can verify that. 6% of $12, 0.06 times 12 is indeed 72 hundredths. Let's do another example. A store has a 25% off sale on coats. With this discount, the price of one coat is $34.50. What is the original price of the coat? So once again, pause this video and see if you can.
$34.5 divide both sides by 0.75. So we're gonna have 34.5 divided by 70.1212. So by 4 we have 300, 450. And then it's gonna be by 6, 3, 5, 450, 46. Okay. The original price is $46.
And these examples, they're actually quite useful because you will encounter this all of the time when you are shopping or you're trying to calculate tax or you're buying something. So think about this. Can you figure out the original price of the coat?
Yeah.
All right, well, let's just write it out the same way we did last time. So let's say original price, and then there's a 25% discount. So minus 25% of the original price, original price, is going to be equal to $34.50, is equal to $34.50, because that's the price with the discount. So can we solve for the original price? So one way to think about it, this is 100% of the original price, or 1 times the original price, minus 25% of the original price is going to be equal to this.
That's literally what I did.
Well, 100% minus 25% of something is going to be 75% of our original price. This is why people use letters for variables, so they don't have to keep writing this over and over again, is going to be equal to $34.50. And now, to solve for our original price, we just divide both sides by 75%. And 75%, that's the same thing as 75 per 100, or 75 hundredths. So I could divide both sides by 75 hundredths. 75 hundredths. On the left-hand side, these two are equivalent, so I'll be left with my original price. And now I just have to figure out, what is this going to be? So if I take 75 hundredths, and let me actually multiply both of these times 100. So this is going to be the same thing as 3,450 divided by 75. I just did that to get rid of the decimals. I moved essentially both decimals to the right 2 places, multiplying the numerator and the denominator by 100. So let's see how many times 75 goes into 3,450. See, 75 doesn't go into 3, doesn't go into 34. It does go into 345. What is that? 4 times? 4 times 5 is 20. 4 times 7 is 28 plus 2, 300. And then you subtract. You have 45. Bring down the 0, 450. 75 goes into 456 times. 6 times 5 is 30. 6 times 7 is 42 plus 3 is indeed 45. We luckily have no remainder. So this right over here is going to be equal to $46. Our original price is 46. You take off 1/4 or 25%, you're left with $34.50. And that makes intuitive sense as well. Always good to just take whatever answer you have and put it back in and see if it makes sense in terms of, if somehow you got $460, instead of taking 25% off, you get to $34.50. You said, well, that sounds off. Or if you got $4, he said you take 25% off and you got $34.50. That would have also felt off. But $46 feels right. And you can even calculate that. What is 25% of $46? Subtract that from 46 and you should get $34.50.
Few more videos.
Jess recently started a business producing cosmetic products made from natural ingredients. Jess recently started a business producing cosmetic products made from natural ingredients. She wants to advertise her products by distributing bags of samples in her neighborhood. She calculated that it takes her 2 minutes to prepare each bag. How many hours, this is interesting, they give us minutes here, now they want hours. How many hours will it take to prepare 1,200 bags of samples if she asks 7 friends to help her with her work? So one thing we can think about is, how long would it take her to do it by herself? So it takes her by herself 2 minutes per bag, and then we have 1,200 bags. 1,200 bags, not 12 bags, 1,200 bags. 1,200 bags, which means it's going to take her 2 minutes for each of the 1,200 bags. Well, that's 2 times 1,200 is 2,400 minutes. Now, that's if she was just working on it by herself, but she's got 7 friends. And we can assume that they would all take about 2 minutes to prepare each bag. Now, this is a little bit tricky because you might want to divide this by 7, saying, hey, we're going to have 7 times as many people. But you remember, she asked 7 friends, so there's actually 8 people involved. There's Jess and her 7 friends. So it's actually going to be 8 times faster than if Jess did it by herself. So we're going to divide. This is if you only had 1 person. If you're going to have 8 people, you are going to take 8 times less time. So with 8 people, it's going to be 2,400 divided by 8 is 300 minutes. And we're almost done, except for the fact that they asked for our answer in terms of hours. So 300 minutes is how many hours? Well, you have 60 minutes per hour, so you could say 300 minutes, I'll just write min for short, divided by 60 minutes per hour gives us 300 divided by 60 is 5 hours. So it will take Jess and her 7 friends, a total of 8 people, 5 hours to prepare all of her sample bags.
That's insane.
Jess Sandy is taking a cab in New York City. The taxi fare includes a base charge of $2.50 as soon as you enter the cab, plus an additional $2.50 per mile traveled. If Sandy starts off with a $20 bill, takes the cab for 5 miles, and leaves a $1 tip, how much money will she be left with? Well, let's first just think about how much this 5-mile cab ride is going to cost her. So the cost, cab, I'll call it the cab fare. Cab fare. So it's going to be $2.50 just when you get into the cab, plus $2.50 per mile, plus $2.50 per mile. Well, she's going to go for 5 miles. 5 miles times $2.50. Right this way. Times $2.50 per mile. So the cab fare here is just going to be $2.50. This $2.50 plus 5 times $2.50. Let's see. 5 times $2.50, that is $12.50. So this is plus $12, $12.50. 250 plus $12.50 is going to be $15. So just the cab fare is going to be $15. And then Sandy gives a $1 tip. So fare plus tip is going to be equal to the cab fare, $15, plus $1, which is equal to $16. So then answering the question, how much money would she be left with a $20 bill? Well, we could write her change is going to be, she's going to give a $20 bill. The fare plus tip is $16 plus minus 16. So she's going to have $4 left in change.
School report.
Joelle is working on a school report in a word processor. She wants to place a figure which is 13.09 centimeters wide so that it appears centered on the page. The width of the page is 21.59 centimeters. How much margin should she leave on the left so that the figure is centered? So let's visualize what's going on. We have a page that's 21.59 centimeters wide. So this distance right over here is 21.59 centimeters. So this right over here, that is our page. Let me draw the actual page. We draw that in white since paper tends to be white. So this is her page. Her page is 21.59 centimeters wide. It's just like that. It's a little unusual dimension for a piece of paper, but we'll go with it. And then she wants to place a figure that is 13.09 centimeters wide in the center of the page. So the figure I'll do in magenta. That's not magenta. The figure is 13.09 centimeters. So let's say that this is the figure right over here. So this is the figure that she wants to place in the middle of the page. So this is 13.09 centimeters. 09 centimeters. So the question is, how much margin should she leave on the left so that the figure is centered? So they're really asking, what should this distance be here so that the figure is centered? And the key thing is, if the figure is centered, this distance is going to be the same as this distance, so that the figure is right in the middle. Whatever this is going to be the same as this. So one way we could think about it, we could say, okay, let's take 13.09 centimeters from 21.59 centimeters, and if we do that, then we'll be left over, we'll know how much leftover space this plus this combined is. And then we just want to split that space in half. We want half of it to go on the right side, and we want half of it to go on the left side. So let's see how much this left margin and the right margin combined need to be. And that's just 21.59. That's just going to be 21.59 centimeters minus 13.09 centimeters. And this we get to, let's see, this is 8.50 centimeters, which is the combined margins, not just the left and not just the right. This is the left plus the right margin is 8.50 centimeters. This is this distance plus this distance. Now, if we want to figure out what the left margin should be, if we want to center it, well, we just want to split this evenly between the left and the right margin. So we just want to divide this by 2. So if you divide 18.50 by 2, or multiply it by 1/2, I guess, that might be a little bit more obvious either way. So if we multiply this by 1/2, you are left with half of 8.50 is 4.25 centimeters. So if we want it centered, this is going to be 4.25 centimeters, and of course this is going to be 4.25 centimeters as well. And you see, when you add 4.25 to 4.25, you get 8.5 centimeters, and then you add that to 13.09, you get the entire width of the piece of paper. So how much margin should she leave? On the left, 4.25 centimeters.
Bit of a break again. Okay, cool. Let's resume. Oh man. I'm just gonna finish to the fourth quiz. Then I'm gonna call it Wow, I've already lost just because I took a rest. Estimated 3 out of 25 men are left-handed. So 3 out of 25 men. So times 4. So times 4 is 12%. Yo, okay. What kind of party they want to have to celebrate their excellent behavior? Out of all the students in the class, 5 wants an ice cream party, 7 wants a movie party, 10 wants a costume party, and the rest are undecided. If 20% want an ice cream party, how many students are in the class? Okay. How many students are in the class? Hmm. Holy shit, this is hard. Oh my god. So 5% are already. So if we multiply 25, if it's 100%, it'll be 25 students. Oh my god, I could be wrong. I know. Let's see. 10, 17, kind of makes sense though. So if 20% wants an ice cream party, and then that's that's 5 of them. If 100% of them, then it's gonna be 20 times 5. Let's see. Cool. Okay. So if you're eating 50-gram chocolate bar which contains 30% cocoa, how many grams of cocoa are in the chocolate bar? 50 times 0.3, 0, 15. Of the 50 US states, 4 have been start with the letter W. Okay. 50 divided by 4, I guess. 12.5, I guess. Oh man, sucks. 220. Oh, fuck. Wait, what? Oh my god, that's insane. Yo, I guess it's because 50% of US states have 4 names that has W in it, right? So is it the other way around? It should be like this? I don't know. It should be though. This doesn't make sense. I'll start the shit. So like 50 of the US states. Yo, is this 8? Oh no. I'm overthinking stupid shit. When a grizzly bear hibernates, its heart rate drops to 10 beats per minute, which is 20% of its normal value. When it's not hibernating. Okay, so if it's so we have probably x 0.2x equals 10. So 0.2. So we have 150. Zero 0.03, right? 1. Wait, what? 960 kilobytes. 0 0 0 0 6 9. Like 2 of them. Oh, it's actually 30%, not 3%. Esteban is a big jar of change in his room. He has 600 coins stolen for pence. What percentage? Sometimes it could be confusing. If should it be like that or the other way around? Man, that can be really confusing, honestly. 2.4, 40%. Okay, I made one mistake, so I'm gonna try again. I hate word problems for real. Challenger Elementary School has 800 students. Every Wednesday, 12% of the students stay after school for chess club. So I'm just gonna find 12% of that. So 0.200 16 008 0069 96. And just to be sure, 800 times 12 16 0 for that, and then 008 00696, and then 2 decimal places, 96 to that. And also 6 of the 8 planets have moons. What percentage of the planets have moons? 6 divided by 8. 6 out of 8, so yeah. So 60, we have 7, 56, 40, 0.75, 75% of moons. John is a quarterback. This year, he completed 350 passes, which is 70% of all the passes he's attempted this year. How many passes John attempted this year? Wait, what? He completed 350 passes, which is 70% of all the passes he's attempted this year. Oh, okay. So 0.7 x equals to 350. So we just have to divide by 0.7, or 3,500 divided by 7. with 5 here. Okay, so 500. Darius buys a bottle of chemical solution that contains 70% alcohol. Are how many milliliters are of alcohol in the solution? 0, 0, 0, 0, 0, 35, 512, 350. Yo, this is the reverse of the other question. The nickelback shit. A gumball machine contains 23 green gumballs, 53 red gumballs, 34 blue gumballs, 61 yellow gumballs, and 13 gumballs. What percentage of the gumballs are red? Oh my god, I have to add all of these. 23. Can I use a calculator? Please give me a fucking calculator right now. Let's add this first. 34. 23, 52, 34. 3, 5, 9, 109. Plus 61. We have 70. Okay, so it's a total of 200. Red. Red is 52. 2, 400, 120. Do that shit. 5, 6. 26% are red. Anastasia is grocery shopping with her father and wonders how much shopping is left to do. We already have 60% value money. Her father says. Okay, so 12x. Oh no, not really. 0.6x is equals to 12. Anastasia is grocery shopping with her father and wonders how much shopping is left to do. We already have 60% of the items on our list. Her father says. Okay. So we have 12 divided by 6. Proficient. Oh my god, it's insane. It's a lot. A caterpillar eats 140% of its birth mass in one day. The caterpillar's birth mass is m grams. Which of the following expression could represent the amount in grams the caterpillar eats in one day? Times m 1.4 m. Choose two answers. I guess this still makes sense. Oh fuck, they don't. I should stop. I should stop. I should stop. Immediately. I should double check. Bullshit answers. 1, 2, 14m. The amount of sodium per serving in milligrams. Oh, choose two answers. Um, the old recipe contains X milligrams of. Okay. If is this X referring to the old one or the new one? Alright, it's referring to the old one. So this would work. 0.67 would work as well. Oh shit, what? It's correct. Oh shit, it's 33x. It should be 0.33. This one. How about this one? No, not really this one. This should be this one. After learning how to fly, Wendy reduced her doom by 75%. Okay. 0.75 m. Alright, so you only have 0.25 minutes. Or 1/4 m. Oh, let's keep practicing. Gosh. Bo is buying a board game that usually costs B dollars. The game is on a sale and the price has been reduced by 18%. Which of the following could represent how much Bo pays for the game? Choose two answers. So this would work. 0.82 B. Yeah. And the other one would be B minus 18 point B. Yeah. After the outbreak of a mysterious disease, the average wait time at the hospital increased by 70%. Before the outbreak, the average time at the hospital was M minutes. Which of the following currents could represent the average wait time after the outbreak? So it increased by 7, so 1.7 M being an increase by 7%. And this one as well. No. London spent LRs at the beach last weekend. Mateo spent 15% fewer hours at the beach than London did. Which of the following expression could represent how much hours Mateo spent at the beach last weekend? Okay. So it is L minus 115? No, it's not work. It doesn't make sense. This one would work. L1 minus 50. Okay. Also, this would work. No. Actually, not this. Not T, but T. 327 is 15%. So, if I deduct 15%, okay, cool. Makes sense. After Batman brought the Joker to justice, the crime rate in Arkham City decreased by 12%. Previously, the crime rate was a C incidents per 1,000 people. Which of the following expression could represent the crime rate in Arkham City? After Batman brought the okay. C incidents. Let's see. So, I guess 88C would work. And also, no, not 0.12C. Let's see. This could work as well. C divided by 1.12. I'm not sure about that. Same as 1 times, oh shit, wait, what? Divided by 1.12. 1. So, holy shit, I just did the same shit. Can it be over 1? Doesn't make sense. It doesn't make sense. I'm sure it's 0.88. See, this could be a thing as well. I don't know. If we simplify this shit, let's see. Oh man, I don't want to get this wrong, please. This is clearly not the answer. This could be either of these two. This kind of makes sense, but this one kind of makes sense too. But this one's in a way of simplifying bullshit. I mean, 22 over 25, that's a simplified version of the thing, right? So let's see. 88 over 100, 12%. It's gonna be 88, right? So if you simplify this, we have divided by 4, we have 25, and this is gonna be 22. Okay, that makes sense. Cool. In a video game, Val scored 30% fewer points than Pita. Pita scored 1060 points. How many points did Val score? So if 10, it's gonna be 1060 times 0.7. 2, 4, 7, 7, 4. Swimming pool had 2.5 million liters of water in it. Some water evaporated and then the pool only had 2 millions. How much water evaporated? So we have 2 now and 25. Let's see. Uh, 0.8. 80%. What percent of the water evaporated? 20% evaporated, right? So, oh my god, cool. Aiden had a goal of finishing painting at least 80% of the 500 square meter of a house. Finishing painting at least 80% of the 500 square meters of a house walls by today. He's vandalizing stuff? The fuck? He actually finished painting 415 square meters today. Did Aiden meet his goal? Why? Okay, so times 0.8 0 0 400 and 0.8 is just one stuff, so 400. Yes, Aiden painted 415 square meters, actual 15 more than his goal. Savannah had 15 hours blooms last year. This year she had 15% more iris blooms. How much more iris blooms did Savannah have this year? I guess so we're gonna grab like 40 plus 40 times 0.15. So let's do 40 times 15 first. 0, 20, 0, 0, 4, 6. Okay, so what am I doing? 40 times 0.15. So we have 0 and 20. Then 0 and 0 for that, and then 4. Okay, so we do have 600, and then 2 points, just 6. How many more iris bloom did Savannah have this year? Just 6. 6 more bloops. Tax and tips. Oh my gosh, I hate this. Ming took a cab across town. His fare was 22. And he lives an 18% tip. What the fuck? What is the total amount of Ming pays the cab driver? His fare was 22. And if you're 18% of that, I believe that's what he wants, so 16, 18, 0, 2, 2, 6, 10, 400, 4. Okay, so 18% per and 4. How much the amount of 26? No way, no way, I'm wrong. I'm wrong about that? Maybe I'm wrong about the calculation about this one. Okay, 16, 18, right? 0, 2, 2, 6. Oh my fucking god. 10. 4.06. Oh. Wait, what? I'm still correct? 16, 18. And then 0 for that. And then 2 and then 2, 6. 8 is 10. 3, 4. 2 decimal places. 4.06. 22 plus 4.06. Minus 6.06. What is this percent? Yo, this doesn't make sense at all. So 22 plus 22 times 0.18, dude. What the fuck? $16. 16. Yo, what the fuck? Whoa, what the fuck? I got different answer this time around. What the hell? What the fuck did I do earlier? What the fuck did I do earlier? 16. 16. 17. 2. 2. 6. 9. 3.96. What the fuck? What the fuck? Yo, what the fuck did I do earlier? That's insane. What the fuck? What the fuck? My mind is getting blown. Probably because I'm sleepy. I don't know. How much tax would you pay on that item? Am I supposed to get the point? I suppose, yeah, $0.12 dollars. Oh, okay, cool. Why? Round to the nearest hundred or cents. Oh, okay. Caleb bought groceries and paid one in sales tax. What? Caleb bought groceries and paid 1.6 in sales tax. What is something that would result to 2.5? I don't know. Oh my gosh. Get a hint. Six. 1.6 of what number? I've already oh my god, why do I forget this? 1.6 is equals to, let's try again. Yo, it changed. What the fuck? Oh. Tiffany buys a watermelon on sale for so we're gonna grab 9 times 0.09, okay, plus 9, 9.81. Camacho is buying a monster truck. The price of the truck is X dollars, and he also has to pay a 13% monster truck tax. What if the following express could represent how much Camacho pays in? Okay, 1.13. 1.13x. Mia hired a moving company. The company charged $500 for its services. And Mia gives the movers assist. Okay, so I guess I'm gonna get Mira's breakfast at a restaurant. She leaves 20% tip off 1.8. What is the price up before tip? Oh my gosh, what is this? $20 of x equals to 1.8. So we divide both by 0.2, right? So just move that shit around. So we have 180 divided by 20. It's gonna be 9. No, no. It's 9. I don't even need your calculator, bitch. Ba, 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 ba. Gabriella bought a new pair of glasses at the store when they were having a 30% off sale. If the regular price of their glasses was 72, how much did Gabriella pay with the discount? Okay, well, this one seems easy. So 72 times 0.7. Okay, so Daniel works at a nearby electronics store. He makes a commission of 15% on everything he sells. If he sells a laptop for $293, how much money does Daniel make in commission? Wow, this was easy. $43.95. $293 times 0.15, we have 40.95. The manager at Gabriella's furniture store is trying to figure out how much to charge for a bookshelf that just arrived. The bookshelf was bought at wholesale for $147, and Gabriella's furniture store marks up all furniture by 60%. Wait, what? Oh, so I'm gonna increase this by 60%. Okay, cool. 147. Oh, 14. Oh my fucking god. 147 plus 147 times 0.6. There we go. So we have 235.2, bitch. Zoe paid 18.6 in sales tax and tips for her dinner. The sales tax rate is 11% and she tipped 20%. The sales tax does not apply to the tip, and the tip is based on the price of the dinner. What was the price of Zoe's dinner before sales? And what the fuck? This is insane. I don't even have a calculator. What the fuck? Okay, so Zoe paid 18 in sales tax and tips for dinner. It's combination. So tax plus dinner. Actually, not dinner, tips. Let's just call it ST plus tip plus 18.6. Okay, 18.6 in sales tax and tips for dinner. The sales tax is 11% and she tipped 20%. The sales tax does not apply to the tip, and the tip is based on the price of the dinner before sales tax. Wow, this is hard. The sales tax rate is 11% and she tipped 20%. The sales tax does not apply to the tip, and the tip is based on the price of the dinner before sales tax. Yo, this is hard. So I guess this is already like 33% in total. Let's see. Paid 18.6. The sales tax rate is 11%. And she tip. Okay, so this is raw. I guess 18.6 is 33% of the bullshit. Okay, so 33, not 33, just 31 actually. 31x is equals to 18.6. So if we multiply with 31, divide actually by 31, and this one as well by 31, we'll have 186. We have 1 2 and 1 2 divided by 31. 31 goes into this guy. 31 times 6, 6 18. Wow, okay, 6 1 8 6. Okay, so $60. Oh yeah, man, so good. Get good. $60. Oh my god. One more practice and then a quiz and then I'm done. Okay. Kirsten runs a website that helps people learn programming. Every month, Kirsten receives a subscription fee of $10 from each of the subscribers to her website. Last month, the website had 100 subscribers. 100 subscribers from first month. So that's 1,000, I guess. This month, 30 new members joined the website and 10 members canceled their subscription. So it's gonna be 20. So 120. This month. Does this have? Fatima conducted an experiment where she asked people to estimate the temperature of glasses of water. She recorded how far the estimates were from the actual temperatures using positive values from guesses that were too high and negative. What the fuck? This is this is nowhere around fucking percent problems. What is the mean value? I think it's like the average of all the shit. What is mean value? Okay. So let's see. This one cancels out. This cancels out. Cancels out. 3 3 5. Okay. So we have 10, 15, minus 6, we have 9. And 9 divided by 1, 2, 3, 12. 12. Times 5 is 60. Let's do times 8 if that's wrong. 8, it's 96. I'll say 7. Shit, this doesn't even work out as well. 714, 784, 784, 6, 5 points. Ellie's backyard has a 6.25 by 6.25 patio. She would like to build a 1.5 meter wide extension around three sides of the patio, as a figure shows. She will buy 0.21 tiles. It comes 25 the package. How much package does Alice need to buy to build the extension? What the fuck does this even mean? How much packages does Alice need to buy to build the extension? Packages. What the fuck? Ellie's backyard has a 6.25 by 6.25 patio. Around three sides. Okay. Can you just give me a calculator, please? 10, 12, 31, 0, 10, 4, 5, 12, 0, 0, 6, 30, 12, 15, 6, 36, 37, you have 5, what is this? 25, 10, 12, 6, oh my god, what's this number? 1, 2, so 630, 6 times 12, 15, 5, okay. 5, 10, 1, this is 7, oh my god. 6 times 6, 36, 7, 8, 9, 3, 1, 2, 3, 4, 13. What am I doing? What am I doing? 39625, 390, 390, 625. Okay, I got the same shit. Why am I multiplying this shit? Why am I getting the area? Oh, okay, I see. So if we're going to extend that, then nah. I can't just add this, that, on three sides of the partial. So it's probably the same thing as adding 1.5 to the other side, or 3. So we have 9.25 times just one side. So 7.75 Oh man, I don't want to do all this shit. 9.25 times 7%. For real? It's such a huge difference. Yeah, it's a very huge difference. What? Oh my god, am I just supposed to say 3 packages? Oh no. Oh no. Oh no. This is insanely hard. So if you have like 0.25 times 125 times 25, we have, and then that kind of suits one of it, right? And that's a per package. Whoa, what the fuck? What's this? $32.625, I've already got that. Four five, right? 32.625. So let's just say uh 20.88 or 21 packages. I hate this question. This is so fucking annoying. Fatih has 1 printing account. Each sheet of paper he uses reduces printing out balance by Fatih has 1.1 in his printing account. Each sheet of paper used reduces printing out balance by 0.95. Fatih wants to print out a PDF that is 47 pages long. Save paper, he decides to print on both sides of each sheet to print 2 pages on each side of the sheet. After Fatih prints, what will be the balance of his printing account? Yo, you don't even have enough money for 47 pages. Yo, you only have 4, and then you can only print 4 shit. And then if you want to use 2 sides, it's gonna be 8. You can only print 8 pages out of the 47, bitch. What the fuck? Is this supposed to be negative numbers? Printing account? Whatever, man. So there's this is gonna use, let's say 48 divided by 2 to get 24. It's gonna use 24 pages. Yeah, 24 paper assignment. And then 24 times 0.25 times 1 would be 6. So $1 1.1. Oh my god, 1.1 minus 6 0. This no, it's a 0, it's 1. Negative 5.1. Oh my god, I can't even deduct. Yo, 1.1 minus 6. How do you even get to 4.9? Oh my god, I've forgotten. This is insane, bro. "47 pages long." This definitely gonna be 48, 24. And then if we divide it by 4, it's 6. And if you have 6, if you have 1.1 in your account, then you can have negative. Am I supposed to say 7.1? Fatty has $1.1 in his printing account. Each sheet of paper he uses reduces his printing account balance by 0.25. One paper, $0.25. Fatty wants to print out a PDF document that is 47 pages long. To save paper, he decides to print on both sides of each sheet and to print 2 pages on each side of the sheet. So let's say if we have 46, then that would be 23, right? So this 1 page more, then you're gonna have another sheet with one of its pages with a print and the other is blank. So it's still 24 pages. So 24 prints. So 24 times 25, it's gonna be the 6 sheet that I came up with. 25, 10, 12, 2, 4, 8, 4, right? So 0, 10, 6. And then the two decimal places, 1.25. So you have 1.1 minus 6. So why doesn't that work? After Fatty prints, what will be the balance in his printing account? That should be 1.1. Why is negative 4.9 doesn't work? Why doesn't that work? Negative 4.9. Why doesn't that work? Why doesn't this work? What is size 6? It's insane. Let's get a hint. What? Are you fucking kidding me? 47 pages long. How the fuck did you get 11? 47. And to print 2 pages on each side. That's the shit that I missed. So it's 1 minus 3 actually, so 9. Though, why am I such an idiot to... let's see. 1.1 minus 3. Why am I a sucker for this? Why doesn't this work for me? I'll see the difference. So let's do 3 minus 1.1. Oh man, it's so bad. I'm so bad. Because of a problem in the program, the timer in the video player did not begin counting until the video had been playing for several seconds. The player began counting at 0 seconds, even though the video had already played 190 frames. Even though the video had played... Okay. Even though the video had already... Okay. How many frames had the video already played when the time was equal to 3 and 2/5 of a second? What? How do you get a negative 3 seconds time? Man, this is insanely hard. Now 15 and 17 over 10 over 5. You get that much frame. So also the seconds of the past. And then if we have 25 frames per second, then if you multiply that, yo, I'm so fucking high right now. I don't know I don't know how to answer this. Let's see, let's divide 190 by 25 first. Uh, 6, 7, 5, 3, 14, 70, 10, 5, 8, 1, 15. That makes sense. 57.46. Two-thirds is 4/10 though. And I have 6 here. Yep. It's more than half. It's here 4/10. It's gonna be 8/10 if I double that shit. This is insanely hard. I don't get this question. This is so confusing. What the fuck? The timer in the video player did not begin counting until the video played for several seconds. The player began counting at 0 seconds, even though the video had already played. The video plays 25 frames per second. How many frames had the video already played when the time was equal to negative 3, 2, and 2/5 seconds? That's insane. Yo, I can't answer this kind of stupid dumb shit question. Okay. Why are you playing at negative seconds? What the fuck does that even mean? Yo, I don't want to encounter this kind of word problem. This is so bullshit. I'm gonna take a screenshot of this because this is definitely so bullshit. Oh my god, it's so hard. The video had played 85 fewer frames. Adriano runs a website that helps writers write better stories. Every month, Adriano's subscription of EF5 from each. Okay, it's 1,000. Okay, it's 230. Julian's using a biking app that compares his position to a simulated biker traveling Julian's target speed. When Julian is behind the simulated biker, he has negative position. Julian sets the biker to a speed of 20 kilometers per hour. After he rides his bike for 15 minutes, Julian's app reports a position of what has Julian's average speed been so far. This is insanely hard. So, uh, let's calculate. This is so bullshitly hard. Wow. So, for 15 minutes. Mm, This is even in fucking minutes. This is insanely hard. Maybe I'm feeling sleepy. Five, um, 5 minus 2.25. We have 10, 9, 4, 5, 7, so 2.27, 2 or 2 and 3/4 miles of. So the ST, uh, space, a distance 2 point, okay, let's 2 and 3/4 km. Uh, uh, so fucking hard. Can I use calculator? $15. Actually, recently opened a store that uses only natural ingredients. I'm so sleepy. Ashley recently opened a store that uses only. She wants to advertise. It takes one person to do 2/3 of a minute to prepare one. So you have like 2/3 bag per minute. So multiply that by 5. Wait, what? Per one bag. So oh my god, I'm so sleepy, I'm so tired. Can't answer the shit anymore. I don't have any brain power right now. Or am I just idiot right now? Let's see, I had this word problem before. Let's see, what was that? Let's see, I think it was this one, I don't know. Yeah.
Jess recently started a business producing cosmetic products made from natural ingredients. She wants
How long have I been recording? Insane for fucking 4 hours now. I don't even
to advertise her products by distributing bags of samples in her neighborhood. She calculated that it takes her 2 minutes to prepare each bag. How many hours, this is interesting, they give us minutes here, now they want hours. How many hours will it take to prepare 1,200 bags of samples if she asks 7 friends to help her with her work? So one thing we could think about is how long would it take her to do it by herself? So it takes her by herself 2 minutes, 2 minutes per bag, and then we have 1,200 bags, 1,200
Yo, that's what I'm trying to do here.
bags.
Say 2/3 times 1, 5, 7, 5. Can you multiply this shit? Oh my god. So we have 1, 5, 7, 5, 10, 7, 14, 15, 10, 11, 2, 3, 3, 1, 50 over 3. What is this? Sim 6, 8, 9. Okay, let's divide this by 3. 3, 1, 50. 5 by 3, 1, 3, 0, 1, 0, 0, 1, 15, 5, 15, 0, 10, 50. So we have 10, 50 bags if she does it alone. But she has for that's for minute though. Per minute. 10, 50 bags per minute. Now if we're gonna convert that, no, if it with the help of our friends, we can divide it by 5. So 10, 50 divided by 5, 2, 10, 0, 5, 1, 5, so 210, and then it's 210 bags per minute, but we want it to becomes by hour. So can in 60 minutes we have 1 hour. So cancel that shit out. So this is quite a lot. This is pretty big. 60 minutes is equal to 1 hour. So 210 times 60. 210 times 60. 0, 0, 0, 0, 0, 6, 2, 0, 0, 6, 2, 6. What? It's insanely a lot of R's. Student minutes, student bags. Oh, it's wrong. It's really a lot. Let's see this calculator. So we have 1575 times 2/3, right? And then if we're 5 guys, then we have 210. That's 210 bags per minute. Could we just do conversion that I was wrong? 210 bags per minute seems a lot. Oh, it's actually minute per bag. So in 60 minutes we have 1. So I guess 210 divided by 60, right? So 3.5 hours. This is insanely hard. Oh God. Man, I'm not in the mood right now. The average daily balance is the mean of the balance in an account at the end of What the fuck? Supposed to be like that? That's so confusing. I'm gonna take a rest. Day 1 to day 10. It's 9 days. The average daily balance is the mean of the balance in an account at the end of each day is a month in a month. This doesn't fucking make sense to me. Starting balance day 1. And by day 10, what? She deposited 650? Let's see. This doesn't make sense to me still. So if he deposits 615, then withdraw. What the fuck is this? How did you get, why did you multiply by 9? Why did you do that? Why did you multiply that? I don't know this is the difference, but why? Daily balance average? What the fuck? So I guess like if it doesn't change, then it's stuck like that for 9 days. Is that what you meant? So it's just like that for 9 days, and then you add the other shit that is stuck for those amount of days. This is 9. It's 4. Let's do 4 or 9. Okay, whatever. Plus like, what's this? 63. This is so fucking insane. This is so fucking insane, bro. This is so fucking insane. Can't do this. But I get it now. But I do get it now. So 1, 2, 3. Times 9. Plus 1, 2, 3 plus 615. plus, no, actually minus, um, let's actually just add this guy. Uh, 1288, then 128 minus 6 is 3, 1225 times, then minus 120, minus 1168, then so the difference then 5, then win 15 7 times 7 for the last one though. How did you get not from 30? Why say 31 though when there's only like 30 days, bitch? This is insanely hard. Oh my god. Why did we want to do it then? Let's see, 1, 2, 2, 3 plus 6. I'm so tired. I'm gonna continue tomorrow. I'm gonna sleep. Just rational number word problems is so fucking hard, man. It's not even part of the percent word problems. Why is it there? Fucking bitch. Insanely hard. So we're gonna school report in a word processor. Huh? Positions to the right of the leftmost edge. What the fuck does that even mean? I think 92 is definitely incorrect. She wants to place an oversized image which is strip 30.51 centimeters wide. The page is smaller than the image. In the program. That's insane, bro. Damn. The ticket taxi costs $3 plus an additional $2 per month. Alright, so we have 3 plus 1 tip, so essentially 4. Plus 2 times wait, what? Okay. I'm gonna change my I wanna change my shirt, it's so small. I don't feel comfortable. Wow. Getting fat. The fuck. Okay, so Satish is going on a 2100-kilometer road trip with 2 friends, whom he will pick up after 150 kilometers. Whom he will pick up 150 kilometers after he begin the trip. Okay, and drop off when there are kilometers remaining. The car consumes 6 liters of gas for every 100 kilometers and gas costs 1. Okay. He will split the cost evenly when they are together. Okay, so 200 is the total distance. But the first 150 and the last will be for him. So minus 300, you have 1/8. 300 you will pay in full. So this would be already 3.6 for him. And then for this guy, 2-1, they will split evenly. So if how many friends does he have? With 2 friends, okay, so 3. 1/8 would be split into 3. Let's just say 1/8 first, multiplied by 1.20016 16 to 30008100611 It's 2160, and we divide that by 3, we get 7 1 7 120. Seven point two. 7.2 plus 11.8. Is that it? Yo, my oh fuck, it's 7.8. No way. It's just hard. Um, we can remove this other, so it actually 206. Um, 7 Satish. So he will play and be divided by 3 times 1.2. 1.2 actually. Seven 3.6. Oh, it's quite a lot though. Let's do this first, like 180, then divide by 10 per 100. So we have 180 times 1.2 divided by 3, 70. So we have 72 when they are together. Is that incorrect? I answered 10.8 first. Let's think this through again. Let's think this through again. After 150 and drop off and 150 kilometers remaining. So 300 divided. Oh my god. 3, right? So 180 divided by 100. You have 18 divided by 3 times 1. Yo, I got 10.8. This is insane. What the fuck? So 300 divided by 3. Oh, okay. Times 1.2 per gas. 3.6 for the first one, right? So the 150 and the 150, that's 3.6 for him. Then for the remaining 180, they will share. They'll split evenly, right? So 1/8. So divided by 100, have 18. If 18, that's your shit. 21.6 for everyone. To split evenly. If you divide it by 3, you get 7.2. Do you have more than friends? Are you guys one before? With 2 friends. Oh, so there are 3 of them. This is insane. It should be 10.8, but it's not. Oh, 6 liters of gas. Oh shit, okay. I forgot the stock. Why am I such an idiot? Okay, so 10.8 times 6, I guess 64. Oh my god. This is so hard, man. This is so hard. Oh my god, this thing again, so hard. Okay. 20 kilometers per hour. And we want to convert that minutes by 15. And then for each minutes 1 hour. So this guy would die, this one would die. So we'll have 20. Okay, so the simulated biker traveled for 5 kilometers. So let's see that relative to Julian's app report's position report. Fine. So Julian's, this is 2.25. So I guess Julian has traveled 2.75 kilometers, and then let's just calculate his rate. So 2.75 kilometers times DST, looking for speed. So distance divided by time, 15 minutes per hour, right? So times, let's convert this shit first to oh my god, I'm not sure if this is 12. I could be wrong again. I'm wrong. 11. Why did I write 12? Why did I write 2? It's 11, dude. It's 11. Oh my god. I want to kill myself right now. Oh shit, this shit again? Oh, I've solved this one. It's 8. God damn it! I could have been doing this by now. No, no, not. What is this question? It takes one person 2/3 of a minute to prepare one bag. So 2/3 bag per minute times 157 bags. So we're gonna have, and then 10 divided by 4, we have 26.5, but that's minutes. So we have 262 bag min, then we have in 60 min we have 1 hour. Oh, I think it's the other way around. 1 minutes actually per bag. So we have 60 1 hour, so 4.37 hours. No, I don't. Pretty sure I've solved this before, but I'm not sure it's not 4.375. Let's see again. 1575 times 2/3, right? That's the minutes to prepare all the bags. Then of course we can divide it by 4. Actually there's 5 in Ashley and 4 of us, so otherwise 5. Then divide by 60 to make it 1 hour, so 3.5. This one's insane. This one's pretty fucking insane. I hate this question so much. So day 1 to 9. So we have 1, 2, 2, 3 times 9 plus deposit. So we have 1, 2, 2, 3 plus 6, 1, 5 times 5. 15 minus 10 is 5. 10 minus 1 is 9 plus 1838 minus 63 1160 times 7 plus 1040 times, should be 8, but remember it did 9. Then divide that all by 30. Oh my god, should we multiply, bitch? Is this really the answer? Fuck this question. Oh shit, I've already answered this. 10.8 times 6. 64.8, please. Thank you. Oh no, what the this question, this nonsense. I don't want to answer this. Oh my god. I do remember it's 105, but it doesn't make sense to me. It's still. Every month, Adriano receives a subscription fee of $5 for each of his subscriptions. So you have 230 from 200, and then 40 new members in 10. So 30. And then you just have to multiply that by 5, so 0, 15, 10, 1150. 0, 15, 10, 11, 230, right? Cool. Crispy Clover, a popular vegetarian restaurant, introduced a menu that has 20% more dishes than the previous menu. Okay, it's 1.2 and this one. Yeah. David's buying a cheese wheel price at $6 before tax. The store charged 8% sales tax. Oh my god. Okay, so 650. Let's get the 8% of that. So 8% is 0.08. 0.08. But we don't need to do that. We could just do 650, 0, 40, 48, 52. 1, 2. So yeah, so we have $52. So we're just gonna combine that. So $702. Cheese wheel. David is buying a cheese wheel price of $650. Let's try this again. Let's try this again. I don't want to mess things up, right? We don't want to mess things up. Sub 0 here. And we have 40. We have 48, 49, 50, 51, 52. And then 2 because this is actually 0.08. See? 52. So plus 50 plus $2, 702. Cool. We should probably do the same amount as 20%. Yeah, this is a victory. And I'm gonna win out. I'm gonna win now. 20% of 45. This is 20% of 45. This is 20% of 45. This is 20% of 45. Let's go. I'm so glad I didn't encounter another stupid bullshit word problems. It's insane, bros. So hard. Oh, nothing. It took me fucking 4 hours and 37 minutes just to finish this third and fourth quiz. It's so insane. I still have 2 more quizzes. Hopefully they're much easier than the word problems I encountered. It's so hard. Okay, cool. Oh, I don't want to show my bookmarks. Let's see. 70% now. Cool. Wait, why isn't that? Okay, cool. Count of 3. Yet I'm still at part 17. So I'm like 6 parts behind. Okay, I guess that's it for today. This is part 17. I'm gonna continue part 18 later. I'm gonna do another part tonight. I'm just gonna take a bit of rest. Bye.